Magandang morning to everyone. Happy New Year and congratulations for your upcoming success. Konting tulog na lang. Be excited to receive the blessings of God. Bakit top 4? Aim higher. Baka ibigay sa top 1 magalit ka ha? Maybe, well, 5 minutes is not too long. I hope you're now with me. Pasensya ulit sa lamig dito. Nagkaroon tayo ng sipon pero tolerable. Normal lang na dumadaan dito kapag lumalamig yung panahon. But bear with me because once in a while, may paubo-ubo ang lola nyo ha. So we are here today para mag-refresh. Meaning, maybe I will be sharing with you problems you met already in the past. And in fact, I know, alam niyo na to. So refresh lang tayo ha. If you know them, then be happy. Pero kung hindi naman, ito na nga, nagre-review tayo ulit. Refresh natin ang sarili, baka nakalimot lang. So kung may mga tanong, pasensya na kung hindi ko lahat makikita sa screen because my focus is my presentation. But from time to time, I try to look at the screen. Okay, so, basta claim nyo na yan ha. I-claim nyo na yung pagpasa kasi wala kayong pupuntahan kundi maging architect. Minsan na ayaw mo binibigyan ni Lord yung pa kayong gusto mo. Just ask and it shall be given. Remember? Teka, nakinto po yung alin. Hindi ko na-gets. Sensya na. Okay, so I think for 3 minutes, kanya-kanya na natin. Siguro, you can see the screen, refresher. At alam nyo na, ang 122 of your, I forgot the page, 95 or something, of your book. Kung hindi mo kagad makita, then find it now. Page 122 hanggang 378. And it's not a joke. If our discussion is only up to 11:30, I'm sure we will not be able to finish all, but I'll try my best, ha? So yung break natin, siguro 10 minutes lang para mag-review or something, ha? Para hindi tayo magkasya ng panahon. Ito na natin sa 11:30 yung break. Okay. Oh, 192 nga. Oh, sorry. Thank you. Page 192. Let's begin from the, number 122. Kung naumit ko yan, kung nakalagpas ako or something, pasensya. So, 2 minutes is already very close to 7:30. Let's begin. Okay lang ba? Okay lang, architects? Okay. Excited ang paus niyong lola, ha? Here na. Okay. Ang reason bakit ina-advertise ko yung aking ano ba ito, email address. Kung may tanong kayo na sobrang personal, wag lang pera ka. You can email me, but bago sana mag-board exam, ma-receive ko yung questions. It can also be through JPT, of course. I can collect all of them and then transmit it to the JPT. JPT will, in the long run, give to you. However, that will take a long time. Working pa ng lola nyo kaya, I cannot promise I can answer right away. So, as soon as possible, send nyo na kagad yung tanong. Kung makakaya ko ngayon sagutin, ngayon na. Pero kung hindi, i-research ko pa sa inyo, ha? Hindi tayo matandaan ng lahat. Ay, malamig na. True. Sa Baguio nung nakaraang Pasko kasi nagka-14. Yes, okay na, napala. Okay. Now let me go to number 122. We are asked to differentiate between tension and compression when they are located in structural members. When we talk about structural members, it can be beam, slab, column, and footing. So, maraming parte ang nilagay nyo. But I am talking about the major parts. Ulit, beams, slabs, columns, and footings. Yung purlins, floor joists, and other small things. They are also structural members, but those that are really carrying so much load, yung binanggit ko na yun. I hope you still remember. Therefore, we'll now move to the definition. Let me begin with tension. Alam niyo naman na, ang tension is the product of pull, compression, push. How will you relate this to beam, for example? Pulling force, I cannot imagine what you do when you pull a beam. That is not possible, di ba? Kaya, we can think of other members of your building or anything that you try to pull and there is a tendency to elongate, then you apply tension to that particular member, and the effect is, it might be elongated. There is no deformation. Okay? It will tend to elongate. However, compression is the result naman of pushing. Diniinan mo, kaya pwede siyang compress. So the result of this is shortening. Kung ito ay bar, when you compress, there is a tendency it will reduce in length. Yun lang naman. However, there is also part in the beam or even column slabs and footings that are subjected to tension and compression. We will show later. Ito muna ha, yung simpleng bagay muna. So this is the bar or maybe rod that I was talking about a while ago. So if you pull this, even if you consider only the weight, ang tendency pa rin ay atakin siya pababa. It is suspended at A. Therefore, the tendency to elongate, this will produce delta sub P, meaning the elongation due to the pull or due to the P force. While, if it is conversely compressed, kagaya niyan, itama nyo na lang yung arrow na yan sa gitnang maski acting at the centroid of the bar. Suppose there is now a compressive force, the tendency is to get a total of deformation also ang tawag dyan, that is compression or shortening. If you remember, kung i-relate pa natin to sa definition ng NSCP, stress equals force per unit area. The force that is developed in the bar, if you divide it by the cross-sectional area, we will get the stress, leading to design. Kasi if you know already the stress, actual stress, all you need to do is investigate the stresses produced. Ano yung mga stresses na yun? Siyempre, kung action load ito din, it's for action. Alright? And then you will be able to check if the dimensions are sufficient to carry the load. Anyway, differentiate lang naman. So, let's not go further. Ito naman, kaya ito nasangkot, when you try to push or compress, there is no tendency for column to be crushed. So, in fact, by definition, short columns fail by crushing. But that is because of the push. Diba? Na idiin mo siya, pwede siyang mag-fail. That maybe, we are not anymore interested to compute for the amount of deformation or shortening. Kasi pag nag-fail siya, para saan pa yun? Replace mo na. O kaya, Anong repair bang gagamitin mo dyan? If you need to repair, retrofit, whatever. Solutions, engineering solutions should be prepared. Ito ang sinasabi ko kanina, what if you're talking about beam? Alright, so from the load given, the upper part of the neutral axis is subjected to compression and the lower is subjected to tension. Only if it is a simply supported beam. Okay? So, once I forgot the year, binigay ko sa exam, where is the compression zone of a beam? It was not specified if the beam is simply supported or cantilevered. So, nahirap yung sasagot na lang ng, yeah, it is on the upper part. Nasa side mo kasi, simply supported. What if it is cantilevered beam? So, the tendency is to deflect this way. Therefore, anong mangyari sa taas? It becomes tension. Sa ibaba naman yung compression. So, makikita natin yan sa bakal. Even in the plans, structural plans, you will notice that the number of bars at the tension side is always greater than the bars in the compression side. Bakit? We know that concrete is very good in compression, but weak in tension. That's why, babakalan natin siya para katuwang ng concrete. However, there is what we call compression bar dun sa kanilang compression side. Mayroon din tayo nilalagay na bakal because we are required by code to provide stirrups. Kaysa may kakapit yung stirrups kung wala kang bakal. The good news is, the bakal that you provide on the compression side will help the concrete kaya nare-reduce yung volume ng concrete. Isasama sa computation. Not only the compression bar serve as a hanger, but also part of the compression strength. So, yun ang effect. So, ulitin natin sa kanan naman, this shows that if the concrete is compressed, maaaring magkaras din siya. There is also a possible failure. At lalong, dahil malutong siya, di ba? Very weak in tension. Pag di mo binakalya niya, maaaring magkaganito. So, nag-crack. At ang worst case, gumapang ang crack mo pataas. There could be a possible shear failure. Mahati ang iyong beam. Maghiwalay. Okay? So, the reason naman why we provide stirrups, ang dami na natin nag-discuss, pero sana nakikita nyo yung kabit-kabit na needs ng ating mga bakal na yan. That's why, ang stirrups are also considered web reinforcement o kaya shear reinforcement. Hindi lang yung mga cracks na yan kasi ang crack na yan pwedeng diagonal, pwedeng straight na vertical. So to resist those forces on the diagonal and horizontal and vertical also, that will be taken care of by the stirrups. Okay, so sana nabasa rin ito. The top of the simply supported beam is in compression, the bottom is tension. Pero sa cantilever beam, ang tension, okay, the top is tension and the bottom is compression. Clear na? Okay, ngayon, what if we continue discussing not only simply supported but this is fixed-ended beam or perfectly restrained. So kung ito-drawing natin ang elastic diagram, ito yung broken line na to, is actually your elastic curve. So, kita nyo naman na kapag hindi simply supported, it is perfectly restrained, kukurba muna siya, concave down, and then up, and then down again. So parang kung i-continue mo siya, merong imaginary line going in this part. The reason why, kapag ganito yung mga usapan, marami pa rin bakal sa ilalim, pero pagdating dito sa may column, may binabaluktot na bakal to join the compression bar. Okay? So, A is just simply the fixed-ended beam, loaded, but B gives us the elastic diagram. Dagdagan na rin natin ang diagram natin from the moment diagram. It shows the inflection point. Saan naroon yung inflection point? Yung point where the concave down separates with concave up in the elastic diagram, alright? Ang concave down na yan at ang concave up maghihiwalay where at the inflection point. Ganun din sa kabila. Incidentally, this is also the location of zero moment. If you draw the shearing moment diagram, you still remember how to do it. Kung sana natatandaan pa na, what if you are given perfectly restrained beam and then you are asked to determine the moment, the maximum moment. May computin mo muna dyan yung reactions, yung mga reactive elements, and then, saka ka palang makaka-draw. But anyway, in the wordings of recently, wala na kayong hirap, pipili ka na lang. So, that is the trend now for several years ago. Hoping the same thing. Ang tawag naman dito continuous beam with response. If you're going to load this, look at the elastic curve. Itong pwedeng mangyari sa beam mo. So, what will happen here is that, ang first span will have a curve like this, and then at the second support, concave down, then concave up at the middle of the second span, down again, and then up. Ganyan na pa, ulit-ulit lang na ganyan. The reason why, if you have a continuous beam in real life, you will see also the bars at the tension side is always greater than the compression side. May mga kapag simple lang din, pare-pareho na lang yan. Kunyari, dalawa sa taas, dalawa sa baba. Wala problema naman yan eh. If simple, mga residential pa. Pero kapag building na pinag-usapan natin, when I think of building kasi, I'm talking of commercial na kasi yun ang malalaki. Diba? Kung bahay lang, baka hanggang 2 spans na lang. Pwede rin 3, bakit naman hindi? I-mention yung bahay mo. So you will also see that there is a part of compression part and tension part. Ulit-ulit lang, ano? At the location of support, especially second support, tension is up or above, nasa ilalim ng compression side. So, makikita natin yung bakal in real life, mas marami dun sa gitna, tapos pabaluktutin to join the upper part on the first support. Hanggang sa okay. In the plan reading, you will realize that itong mga analysis given to us are correct. Also, you will see the points of inflection. Ito na bubuyaw pa nga. Okay. So, tensions and compressions also can be computed in process. In fact, if you have a simple task like this, itong mga arrows na to, positive, kasi binigay yung yung kabuuan kung ano yung meron sa A at sa B, o kaya sa D at sa E, saan ba ang support? Well, you can consider this as support and then there are loads given in there. Considering that this is the free body diagram, and I assume joint method, if I consider joint A, look at this, I can compute for the member forces. So, the force in A, here, kapag ito towards, from the joint, going away from the joint, this is tension. If it is naman sa E, this member going to the joint, that is compression. Para sa anong mga ito? You will be able to determine the forces in each member, and then after computing that, pwede mo nang gamitin yung stress equals force per unit area. If the stress, halimbawa, gagamitin mo bakal, the FY is almost given to us, given natin yan. Ano bang grade ang gagamitin mong bakal, then you can compute for the cross-sectional area. Yun ang tinutumpok ng mga usapin na to. So we are not stopping here in the determination of the bar forces, either compression or tension. Kaya natin kinocompute, we want to know how big the area of the section or the size. So syempre, ito ay very body diagram lang, but this is true in real life, but we will not compute anymore because in the recent world, for about more than 5 years already, you are not given computation anymore. That's the good news. So ito yung nasa kanan is real, in real life, this is true, this is part of your drawing, yung sa plano, sa section ninyo ng truss. Pinakita lang yung isang joint. So you will see that the size of the structure is almost there with all these connecting metals. Kung ito ay, in order to join them, parang in order that the member, the bottom board and the two members will be put together. Parang make it face one. So ayan ngayon ang forces that we develop. Ito ngayon nagre-represent ng isa dito. Kaya there is now a force that is developed in this member, also in that member. So 1 to 20, 123 pa lang tayo. This is not the real question, it is just a clue. Parang aralin mo yung elasticity of steel. Okay, to my mind, if we are just going to define elasticity of steel, then the ability of steel to return to its original shape and size upon removal of load. So, alam natin that steel is elastic, more elastic than concrete, correct? Although concrete also possesses a little of elasticity, but not much. In terms of elasticity, steel tayo kapag pinagkukumpara natin ng dalawang major construction materials. But again, to my mind, there is also a possibility na itinanong sa board exam yung elasticity, yung modulus of elasticity of steel. So you have to memorize this one, the two of this. One is in metric as a unit, the other is English. Ano nga ang 200 gigapascal? This is the modulus of elasticity of steel. What is giga? G, 10 raised to the 9 power. So 10 raised to the 9. Therefore, 200 billion pascal. When it comes to ES naman in English, 29,000 KSI. What is K? That's kips. 1 kip equals 1,000 pounds. You can also say therefore that it is 29 million PSI. Nagets ba? Okay, so I remember one time in the board exam, ito yung tamang sagot. And then in another, 200,000 megapascal. Bakit naging mega? I hope you remember that G is 10 to the 9. Therefore, pag tinara mo yung 10 to the 6, if isasama mo dito yung tatlong zeros, so mayroon kang 200,000. Yung 10 to the 6 na natitira means mega. Mega Sharon. And 10 to the 6 is mega. Okay? So, pinakita lang natin yung stress strain diagram to recall the elastic limit. From 0 up to proportional limit, ito yung mga tinatawag nating the materials can be stretched or pushed. After pushing or after relieving from the push or pull, the material will just return to original shape and size. No problem. Pero, kapag inabot natin ang elastic limit, hanggang doon na lang ang maximum stress that you can apply to material in order to return to original shape and size. Beyond it, it will already yield. So, just a little above it, yung sentrong-sentro ng elastic limit, yield point na. So, pag sinabing yield point na, hindi na siya babalik sa kanyang original shape and size. That's why, even in beams, pagka-deflected siya, may sinasabi ang code. Compute for the deflection and then compare it with the allowable. Meron tayong allowable deflection. Ibig sabihin, pwede mag-yield talaga. So, pag nag-yield siya, teka muna, hanggang dyan ka lang, sabi ni code. So, we need to recall all those limits. Next, difference of tension and compression where they are located. Parang tapos na natin yan. Next, flexural stress without action load. My answer is 0.9 FY. Bakit? It's 0.9 FY because we're talking about flexural stress. I have to remind you that we discussed reduction factor. Again, load reduction factors. Nabanggit flexural stress. Pag sinabing flexure, bending din yan. Flexural stress is also bending stress. Therefore, kapag ang nakita mo from the choices, kasi talagang literally walang ibinigay dito. I mean, nakalimutan siguro natin bubuin. So the answer is 0.9 because, let me show you this to you, table 421.2.1 of your NSCP. Ito. Para saan yan? Okay, ito ngayon ang mga description ng effect of load to the beam. Bawa, yung beam mo is subject to moment. Pag nagkaroon ng moment, may bending siya. Pag may bending, therefore there is flexure. Okay, so ang kanyang reduction factor ranges from 0.65 to 0.9. However, I can choose 0.9 only. Anong meaning nun? You have to set aside a certain 10% allowance allowance for unforeseen work scenarios. Diba, biglang lumakas yung lindol, hindi mo inaasahan na yun ay may exceed, at saka yung ating mga maximum wind loads, hindi mo akalain na signal number 5 na pala, dati signal number 3, signal number 4 in all. So, 0.9. Pero pwede naman 0.65, 0.7, 0.75, lahat po pwede within this range. Ngunit, kapag ginamit ko ay 0.65, nagkaalak ako ng 0.35 or 35% allowance. Kung nakipagbid ako, I will not win there. So, kapag ginamit ko 0.5, safe and economical ito. Ito, very safe and uneconomical anymore. So, siguro, naintindihan na, no? So, I chose 0.9. Kaya, kung babalikan natin ito, 0.9 ang sagot yan. Okay? Mabigay na rin natin yung shear. Ito, ilang beses siya lumabas. Shear reduction factor is 0.75. Torsion, 0.75. So, madaling i-memorya, di ba? Pagka-bearing, 0.65, etc., etc. Please look into this because masyado itong mabenta, malabas. Okay? So, the answer is 0.9. Next, define the following. Wide flange, channel, plane, angle bar, sheet. So, how are we going to define that? Very easy. Siguro, I prefer to give you na lang yung descriptive tayo instead of defining. Although, I have some input here for your information. So, nakakita na tayo ng wide flange. Kung hindi pa, ito na nga, oh. Ang wide flange is like there are parts, meron tayong web, meron tayong flange at the top, flange at the base. Tapos nakikita mo, syempre, welded siya ng maigi dahil ilang 3 pieces na pinagsama-sama. Ayan. Pagka nag-manufacture ka ng kabuuan na yan, buong buo, of course, that's the best. Pero kung pwede namang i-weld naman kasi. Anyway, we see some structural members like this, talagang solid. Yun ang pinaka-the best kasi walang possibility to parang separate ang one from the other. So, I just read this one. The horizontal pieces are known as flanges, ito, top and bottom. And the vertical pieces is called web. Yeah. So, maganda na rin yung makita natin, why provide flange? Why not only web? Kapag web lang, di ang payat. Baka mag-create ng punching failure somewhere. Papatong mo dyan yung slab, di ba? The flanges resist bending while the web takes on the shear force. An I-beam, so yung mas maliit na flanges, has tapered flanges with a narrower flange than most wide flange beams, making it a lighter material. A wide flange beam with wider flanges and web than I-beam can handle more weight but heavier. Obvious naman, di ba? So, itong mas importante, para saan yung flanges? Para sa to resist what? Bending. Para saan yung web? Para naman sa shear forces. Yun ang function, ha? Ngayon, sa channel, talagang literally, it looks like a C. Saan natin nakikita yan? Pwede namang structural member, but more of support beams, like that. Ang plate naman, ayan. So, this is the function. So, we are already familiar with the use of this. Pwedeng bearing plate. Yun bang dalawang, nyari, may pedestal ka, papatong mo doon yung polo. So, kailangan magkaroon ng connection. Before you provide the bolt, meron kang bearing plate. Yan siya. Angle bar as also used as sometimes purlin also pwede. Tsaka member, mga web members of classes. And, anong sheet ba yung pinatinutukoy natin dito? Pwedeng plain, tsaka pwedeng corrugated. Okay, so yung galvanized iron is a sheet also. Yun, so siguro, if the description is given to you, it's easy to select. Next. Analysis of structural plan, measurement of beams, beam reinforcement as analyzed from table, distance of a beam, midpoint, etc. etc. So, we were not provided with all the plans, kaya nag-create lang ako ng sarili na pwede natin maging reference. Anong tinutukoy natin dito sa figures na to? Well, this is floor joist, something like that. Simpleng floor joist na may mga joist ka, tapos may pinaka-beam mo dito, ito yung bearer na tinatawag, and then may bridging tayo, which is also called solid blocking. So, isang araw, binigyan na rin sa boarding sa itong, what do you put now between the floor joist para daw ma-minimize yung lateral deflection, lateral movement. Lateral means horizontal. So, pwedeng gumalaw ang flooring mo. Kasi kunyari, malayo yung distance from one floor joist, from one beam to the other. Pag floor joist lang yan, halimbawa, ito binigay na 3.2, no? Malayo yan. With the solid blocking or bridging, mami-minimize natin yung galaw. Pag masyadong malayo kasi yung distance ng dalawang support, pag tungtong mo sa TNG yun, baka maramdaman mo yung nag-deflect. So, that is not good. Ito naman, reinforced concrete beam, it does not show us only, so it gives us the two types of beams here. One is secondary, the other is primary. So, ang primary beam, we call it girder. So, alam nyo na yung beam lang. So, ang beam, titingnan natin, which is the girder, which is just a beam. Pareho lang beam yan, kaya lang, one carries the other. So, therefore, ito ngayon, this one and this one, yung ABC, yung beam na yan, at saka yung DEDF, itong beam na to, they are called primary beams. Bakit? Kasi kinikerry nila, itong BD, itong CF, itong AE. Okay. So, in addition to that, yung girder mo, your primary beam, is called spandrel. Dahil natanong na rin yan. Pinakita yung drawing, alin daw dyan ang spandrel beam. Now you know that this is spandrel beam because the beam is connected between supports. So, ito naman, non-spandrel. Obviously, if ABC is spandrel, ito ay non-spandrel. Yun lang. Another is floor system. The drawing shows floor framing plan, English unit, and the size of column is 12 by 16. Okay? So, nakikita natin na yung, kung we refer to the drawing, itong y-axis is 12, itong distance, yung size. And then, along the x is 16. So, anong pwedeng tanong dito? One question was, compute the clear distance between, o ikaw pumili, alin gusto mo. Halimbawa, between 1 and 2. Clear distance. How do you do that? Okay, so syempre, kailangan mo ito. If you can only enlarge this, talagang ko lang muna yung enlarge ko ito. So, between 1 and 2, you need to get the clear distance. So, incidentally, yung center to center distance between 1 and 2, 5 and 6 is 15 feet also. So, this slab is square. But, does it matter? Ito yung kailangan natin clear distance. Itong beam na ito pinag-uusapan. So, what you do is, 15 feet, isubtract mo yung bahagi na ito at saka bahagi na yan. Tama? So, ayan na nga siya. Kaya balikan natin yung kanina. If this is 16, therefore, kalahati is 8. 16, kalahati is 8. Therefore, dalawang 8 over 12 ang ibabawas mo. Dangan kasi, this is in inches. So, make it feet, all of them, so that they will be consistent in unit. Try again using the other. For example, 6 to 7. Ayun. So, incidentally, ito 20 nga lang, pero ibabawas mo ganun pa rin kasi yung size niya ay pareho lang. You will just change this one. But what if, determine the clear distance between 7 and 13? O, iba na yung usapan because this length is 20, ibawas mo yung kalahati ng 12 kasi 12 yung along here, di ba? So, minus 6 over 12 and then 6 over 12 or just 12 over 12, 1. Natali, ano? So, yan lang ang inyong math. Yung computation for your math is just a simple arithmetic. No worries. So, well, check na lang the correctness of my calculator. Next, Another drawing that you may look into is clear distance is also defined as effective depth plus. Ayun, so meron tayong holding computation, but never mind. Kung wala kang idea regarding this distance, ito, size na to, yung BS na to, o hindi, ito gamitin mo. Pero kung binigyan naman ng size, ito ka magpapakadusa. Go back to the previous discussion. So, the clear distance is the effective distance. Okay? The clear distance is the effective distance. See-through na connection. Okay? So, may mga label tayo para to understand ano mga yan. So, you see, corbel is not a beam, it's just part of the column na kung saan isasampang mo yung, it will help carry another structure. Alright? And all the bolts there. Also, with the beams now, I mean, with the reinforcement, sorry. Look at this. You will see that the stirrups are closely spaced near the support and then medyo pa layo, pero meron pa din. So, yung isang tinanong noon sa board exam ay, what is the distance from of one stirrup, of the first stirrup from the face of the support? Okay. So, if the drawing is not clear, tingnan nyo yung scale. Kung wala pa rin, tingnan mo sa tabulation, we call it schedule. Dahil makikita mo doon, hindi pwedeng wala siyang information. So, in that case kasi, yung nakaraang exam na yun, the distance of the first stirrup from the face of the support is 50 mm. Pero ang code sasabi na, provided yung space na to, yung stirrup mo na yan, will not be minimum, will not be less than 25 mm. Alam mo kung bakit? Kasi itong column may bakal din yan eh. Magkakabakal ka rin yan, meron, mga vertical. Tapos may, ano ba yan, may, ties, lateral ties. Hindi pwedeng nagkakadikit-dikit. There must be a space. And the code says, it must be enough, the space must be enough so that yung maximum size of aggregates can pass through it. At ang inaalaw natin sa beams, columns, slabs, no, yung maximum size of aggregate on the average diameter is 25. So pagka lumiit pa sa 25, hindi na makakapasok ang graba. Problema yan sa pagbuhos. Okay? With regard to the number, hindi tayo magko-compute. This side is very difficult at this time. We cannot tackle it. Pero, tinatanong kung ilang meron ka dyan. O, ito bilang, walang duling ka. Additional info na, a certain structure may look like this. There are bent bars like this, and you may be asked to determine the total length of the beam of one bar, for example. Consider this. Kaya, kung binigay sa'yo yan, ibig sabihin, not only the length of the beam, diba, with cover, bawasan mo yung cover, plus this one. So, magkabilaan yan. Kaya, meron tayong code in order to determine this extended line na to, extension line. Kapag bent 90 degree, what is that? That will be 12 times the diameter of the bar. So, kung ang length mo dito, given naman ng beam mo, di ba? So, ibawas mo lang yung concrete cover, yung magkabilaan, i-add mo yung dalawang nakapaluktot. 12 times the diameter of the bar. Also, ang mga tinanong ng mga examiner noon compute the number of bars. Ay, ilan ba meron bars? Meron dyan. So, bawal na naman mag-compute, bilang-bilang ka lang. So, the feedback said, yung feedback says na, there's no worry daw. No worries with regard to plan reading. Bonus pa nga kasi madali. So, kapag hindi ka marunong magbasa ng plano, that's the only problem. So, you still have time to expose yourself to real plans. Ito naman ganun din, so mga baluktot, yung total length of the bar, tapos meron ka dito, ito yung stirrups natin, nakabaluktot din. So nakaganyan siya. Oh. So itong baluktot na yan is 135 degrees. Okay, code says that extension line there, yung binaluktot mong pa ganun, meron ka 6 times the diameter of the bar. Kaya we will have an example na para makompute ang total length later na. And I'm just showing the plans. Now this time this is a round bar, round column with the spiral. So we call this spiral column. This is not minimum. We're just showing a plan para makita natin yung, paano yung spirals? Instead the lateral ties, we call it spiral. The reason why round columns or spiral columns are better, stronger than tight column is because, pag titignan mo naman, yung lateral tie ng tight column, iwalay. Ito, tuloy-tuloy yan. Splice mo na lang kung kulang pa. So again, determining the number of bits, you can just divide. Madali, di ba? 250 divide mo, kunyari, 25 ang minimum mo. Hindi ilang pieces. But in real plan, ibibigay sa inyo yung tuturin. So, hindi ka kailangan mag-compute. You don't need to estimate. You need only to get the real measurement, the real number from the plan. Next, it is a column that is symmetrical to each other axis. Hindi ko masyado na-gets, pero ito yung naintindihan ko sa tinanong na yun. Column symmetrical to other axis, I could say perfect is tied column square column and round column pa rin. Meaning to say, meron tayong, if I draw line, vertical line, which is y-axis, and horizontal line, x-axis, makita mo yung bahagi niyan ay magkakamukha. Ganon din dito. So, what if it is rectangular, tied column? Symmetry, okay din naman, kaya lang in two axes, di ba? Meron tayong symmetry with respect to the y, symmetrical with respect to the x, but not in all axis. Ito lang ang perfect sa all axis. Ito, symmetrical in isa lang. Both y, also in about x. So, kayong mag-judge from the plan kasi medyo to the other axis, to each other. Meaning, ito lang ang magpapasa. Ito kasi, hindi magkakamukha. So, pwede, kapag, depende, papalitan mo itong tanong. Okay, so the reason why this is here is for discussion purposes. Only these two qualify for symmetrical in both axes. Now, nagdagan ko na yung discussion dito dahil, nabanggit ko kanina, there was a question about which is stronger, round column or spiral column or tied column. Siyempre, nasagot natin round column for the reason that the minimum bar is 6 agad. 16, minimum yun. Samantala sa tied column, 4, only 4, 16. So para sa columns, tied or spiral, the main bars, minimum diameter of main bar is 16 mm. As to the number, yun, 4 lang sa tied, 6. Sa bakal pa lang nagkatalo na. Kaya, this is stronger. Isa pang reason why spiral column is stronger is because yung spiral nga, nakapulupot, walang tali-tali. Samantalang ang guide column, ties. So, tali mo, cut, tali ulit, certain distance. Okay. Dagdagan ko na lang ha. Yung spirals mo dito, na lumalabas na yun ang pinaka lateral tie, ano yan eh, ang minimum spacing between the pits is 25 mm, maximum is 75. Samantalang dito, medyo po pwede pang mas malayo. Okay. It is a column that is seated on top of non-axial bearing member, like a slab or beam, used to carry loads above. It is usually used to address architectural interior design concerns. Okay, so ang sagot ay planted column. At ito yung example. Thank you kay Sybil Reid. Kasi ang ganda ng kanyang figure. Ito naman, kaya pinakita natin, right figure, seems to be, nagpo-qualify na siya dun sa definition ng planted column. Kaya itong bahagi na to, wala ka ditong continuity, kaya nagiging, ano yan, archi-design nga eh, kayong may mga gawa niyan. Pinapahirapan nyo kami mag-design, kaya ganda. Next. What do you call the column that is not aligned to lower floor column? Planted pa rin, kagaya ng kanina. Next. What do you call a horizontal member of a structure that is fixed at both ends? Na-discuss na natin yan, they call it perfectly restrained o kaya fixed-ended. So, ang example ay ganito. So, thank you, matalino.com for the figure. This is fixed, both ends are fixed. And another is, yan. Ito yung mga types of beams, at ito yung fixed-ended beam or perfectly restrained. Perfectly restrained. Kaya, ito, alam niyo ba na itong beams na to, ginawa nila, pinalitan ng mga pangalan na totoo. Ginawang figure, etc. And then, papadefine sa'yo which one is cantilever, which one is continuous, which one is overhanging, which one is fixed-ended, etc. Dagdagan na lang natin, taken from figure, strength of materials by Pytel, Singer. Ayun, fixed-ended pa rin, na iba-ibang klase yung loading. So, if you memorize at least isa, makakaginhawa yung pakiramdam kasi pwede mong i-relate ito sa simply supported with uniform load. Kasi yung very common, all-time favorite ng examiner. At gusto ko lang punahin nyo ito, maximum deflection. No? Yung maximum deflection, if it is a perfectly restrained beam, is WL to the 4th divided by 394 EI. Listen, kapag ka simply supported beam, meaning hindi siya fixed-ended, magkakaroon ng 5 dito sa numerator. Anong meaning? Kapag ka simply supported beam, 5 times ang laki ng deflection as compared with fixed-ended. In terms, therefore, of reliability, siyempre itong fixed-ended ang stronger. So, magpa-qualify agad-agad dun sa limit na binigay ni code. So, it is better to use fixed-ended kaysa simply supported lang. Parang yung beam mo nakapatong lang. So, hindi yun matibay. Malaki masyado yung reflection. Napapakita natin mamaya, but remember this. Well, if you want to know the others, hindi ko na tinanggal for your information. Okay? What do you call the underlying structure forming foundation of a building or other structures? Substructure? Siyempre, kung meron kang underlying structure, meron kang above naman, the ground. Part of building that's above the ground, superstructure. Okay, so alam niyo na yung kaibahan ng substructure from superstructure, itong illustration. Okay, tingnan nito yung building, ito yung kanyang mga paa, the columns, the footings. Okay, so meron kang nakabaon pa rin. Ito ngayon ang pinaka-boundary, yung ground. Okay, above it, we call superstructure. Below it is substructure. Pero, i-boundary pa rin para to make clearer. Diba? Meron tayong foundation. Kasi this is part of the building pa rin. This is not part of the building anymore. This is just the foundation. Okay. As a rule or convention of sign, alin yung tama? Positive movement is counterclockwise. Negative is clockwise. Positive movement is clockwise. Negative. That's the answer. That's the way we do it during computation. Two fixed supports is indeterminate to what degree? You know it already. How do you know? Draw the free body diagram. Incidentally, kapag fixed siya, tatlo agad ang reactive elements. Tatlo din sa kanan. So, 6. Ito yun. I-subtract mo yung equations of static equilibrium. Tatlo lang yun. So, subtract ka. So, 3 na lang. Kaya, indeterminate to the third degree. Question. Because it is said indeterminate, you cannot compute anymore. You can compute. But you cannot compute using equations of static equilibrium. What means do you need? What computation method do you need to determine the reactive elements? Doon papasok yung either free moment equations method, moment distribution method, ano pa? Double integration method, get well work method, derivative method. Sa dami nun, maaaring hindi na nga rin yung maranasan yun sa board exam dahil hindi namin binibigay ng medyo matagal ng panahon. Okay? Hanggang dito ka na lang. But you have to know how to compute. Okay? So, ito yung equations of static equilibrium. All the forces along x, dapat ang summation yun, 0. All the forces along y, vertical, 0 also. Taking into consideration the sign, ha? Halimbawa, yung mga pakanan, positive, lahat ng pakaliwa, negative naman. Pag nag-0 siya, meaning balance. Yun din sa vertical. Kaya nga kapag may force ka pababa, gravity load, o dapat may support ka. Dapat pag-equal silang dalawa para hindi siya gagalaw. Ganun din sa moment. About acceptance center of rotation. Therefore, kung may kanan ka, dapat meron kang kaliwa. So kung wala kang force na in-apply going counterclockwise, maybe it is the resistance created at the walls. Okay? Recall again the free body diagram of part of your building, of your supports. Kapag roller support, there's only one. Hinge, there are 2. Fixed, there are 3. Simple, frictionless, parang roller. Itong pin support or hinge support, the same, dalawa. Okay? So you can already compute the number of unknowns, subtract 3, and then the result is the degree of indeterminacy. What is flexural stress? It is bending stress. What is it nga? It tends to cause bending or deflection of materials like beam. Did you know that even your footing can be considered may deflection din. Yes, it can bend. Imagine mo yung column, pinupush niya pababa. So, it will create a concave up, no? So, concave up like that. Again, to illustrate bendings like this. Kapag cantilevered, pababa, baluktot naman paakyat yung, yung simply supported. Bakit inulit natin yan? Kasi bending stress na eh. This is the formula in getting the bending stress. So, just until the formula lang tayo kasi mahabang usapin to. What is M? If you really want to compute for the maximum bending stress or shear, flexural stress, you need to compute for the maximum moment. Where do you get this? From the diagram, moment diagram. Ang C naman, if you have the section, and meron kang rectangular, H ang height, B ang breadth. So, ang C mo is kalahati ng I, kung rectangular. Height naman square. Pero beams are normally, wala tayong ginagamit na beam na square. Laging ang height niya is twice the B. Ano naman ang I? Moment of inertia. Ano naman ito? If it is rectangular, ang I mo or moment of inertia is BH cubed over 12. So, those are the things that you're going to look into in order to determine the maximum shearing or bending stress or flexural stress. Okay? What is torsional stress? Obvious na torsion may twist yan, ano? So, the stress produced when the body tends to twist. Okay? Stress produced when the force applied tends to twist the body. Sa mga shaft natin makikita. Yan. This is naman the formula in getting the stress. We call it torsional stress or sometimes we call it shearing stress. So, this is the torque, radius, what R from the solid shaft, di ba? Yan. And then J is the polar moment of inertia. So, kapag ikinumbine mo to, ito na yung itong pinaka-ilalim yung pinaka-general formula. Kapag solid shaft. But if it is not solid, hollow shaft, hindi na totoo. You have to deduct yung internal part. Kasi hollow naman siya. Okay? Additional torsional stresses, pwedeng mangyari sa column, pwedeng mangyari sa beam. In fact, there is a possibility it will happen to buildings. Kaya, there is what we call torsional analysis also for buildings. What is P delta effect? Ito yung definition niya. Secondary effect on shears. Sige na, thank you. Pero kapatwatin kasi sinisipon ako. Pero thank you kasi I need it. Thank you. Secondary effect on shears and action forces and moments of frame members due to the action of the vertical induced by horizontal displacement of the structure resulting from various loading. Pagka secondary effect, may primary effect? Yes, there is. You can compare it with yung bang, ganito, mayroong kakawak na ruler, plastic, make it fixed at the lower part. Medyo kalabitin mo lang dun sa dulo. Tapos bitawan mo na. Yung una, yun ang primary. Nung inila mo siya, para mag-deflect, yun ang primary. Pag bitaw mo, bago siya manahilig, pag-vibrate muna. So, P delta, gets naman ano. We can also compare it with earthquake magnitude. After earthquake, ang PMBOK mag-a-announce, keep safe pa rin kasi there could be aftershock equally dangerous than the magnitude of earthquake initial attack. Kaya, yun ang mga sinasabi natin na, comparable to earthquake aftershock. Kapag ka nag-earthquake, bumuka na yung lupa, o kaya lalo kung may fault line yan, nagalaw lalo. Okay, pagka nagkaroon ng aftershock, ang ibig sabihin nun, yung mga nabumuka na lupa na yan, nagkakaroon pa rin ng reaction. So hanggang sa pag gumanaw pa uli, wow, lalo siyang lalala. Just read this one from Wikipedia. In structural engineering, the P delta effect refers to the abrupt change in ground shear, overturning moment, and or the actual force distribution at the base of sufficiently tall structure or structural component when it is subject to critical lateral displacement. Okay lang. This is very clear, nasa ground siya. Ito applies to any part. Okay, so this is the P delta effect. Delta is pinaka side swing. What is shear? What is shear wall? Shear is just a force. Shear wall is a structural wall. Okay? Shear is a force parallel to the area where the force is applied. Imagine nyo, no? Halimbawa, yung utility core ninyo, elevator, yung walls mo, surrounding your elevator, the machine, is shear wall yan. So, parallel to the area, dahil kasi yung movement ng inyong machine, elevator, up and down. Kaya ito dapat solid. Pero hindi pwedeng kiss-kiss yung elevator mo mismo doon sa wall. Otherwise, will create friction. Very dangerous. While shear wall is a reinforced concrete wall that resists lateral forces parallel to the plane of wall. Hindi perpendicular sa wall. If this is the wall, it's not perpendicular but parallel. So, going parallel. That is possible if there is a strong wind. Okay? Tapos, medyo gustong, hindi siya perpendicular but along this way. Pwedeng i-move kasi yung wall mo. The wall that is reinforced concrete will resist the wind para hindi siya ma-move. That is the idea. Comparison na tayo sa what is shear force. Parang pwede siyang mabiyak na ganito kapag kadali sa push towards that direction and towards here. So, yan, nagkaroon ng splitting. Okay, ito naman yung shear wall, reinforced concrete wall. Sometimes it is intentionally made reinforced concrete kahit na walang elevator. Para bang this will add stability to your building. Depende syempre. A wall that carries no other load except its own weight, non-load bearing wall. It's a wall na wala siyang dinadala kundi sa sarili niya, non-load bearing. Conversely, if the wall carries other loads above it, then load bearing wall na siya. So, ito ngayon dalawa, meron kang non-load bearing kasi nga wala namang sila dinadala. It is only intended to divide, parang partition lang. Pero itong isang wall na to, dinadala niya yung truss, kaya itong wall na to medyo mabigat ang kanyang dinadala, so it is a load-bearing wall. Overhanging beam, the overhang can be in one end, can be at both sides, both ends. Cantilever pa rin, pinapa-differentiate lang sa atin, but siguro by this illustration, you remember that they are different in, not only in supports, this is fixed, so tatlo, dito naman dalawa lang, pero syempre kasi, hindi pwedeng parehong hinge yan, ay parehong roller kasi hindi magiging matibay. One should be hinge, the other may be roller, no problem. Okay, but be sure that in analyzing your beam, you should know what the supports are para ma-discard mo when you draw the free body diagram, alam mo kung ano yung mga reactions that are developed, especially if you are asked to determine what? The indeterminacy of the beam. Overhanging beam pa rin, with load. Overhanging beam, cantilever beam pa rin. So, ulit-ulit. Next. Where will you find the main bars of cantilever beam? Main bars, top. So, sabi na natin kanina, tension at the top. So, the main bars are there. Ito yung sinasabi ko kanina. Na tinanggal yung mga pangalan, di ba? Nilagay figure. Okay, ito na ngayon. From the figures above, identify the continuous beam. Anong sagot? Yan. Continuous beam. Figure 4. Another. From the figures above, which one is overhanging? 3. In both sides. Next. From the figures above, identify simply supported. Kita naman ano? 2. From the figures above, cantilever simply supported. Yan. We call it, para maikli lang, that is also called prop beam. Prop beam. Pero okay lang, andyan na yan eh. Cantilever simply supported, meaning fixed in one end, there is a simple support on the other. But we call it prop beam, for sure. Last, identify the fixed ended. Figure 5. Sana, ganyan lagi, ano? Next, identify cantilever beam. Figure 1. Okay? What is fatigue? Yan ang sagot, ang definition. The stress at which a material fails under repeated loading. It is also defined as progressive fact under repeated loading. So, nagkakaroon ng fatigue when there is repeated loading. Okay, ngayon, dagdagan natin ito ha. If a structure is subjected to repeated loading associated with high temperature, the possibility of failure is we call creep. C-R-E-E-P, creep. Ha? So, yun lang, kapag ka associated with high temperature na. Pero, balikan natin ng fatigue. Ang fatigue strength, ito yung capability niya para malabanan yung repeated loading. The material has fatigue strength if it is capable of resisting the repeated loading. Pero kapag hindi, ito mangyari sa kanya. Okay? Ito pang mga example ng fatigue, effect of fatigue sa surfaces. Okay. Method of joint, method of section. Well, kanina na, banggit na natin ng truss na may method of section, but ito na rin ang definition. For method of sections, by the method of joint analyzing, we need only 2 or 3 equilibrium equations because the procedures involve concurrent force at each joint. Ano to? Joint method. In method of section, has the basic advantage that the forces in almost any desired member may be found directly from an analysis of section, which is has cut that member. Ayusin lang natin ng English ha. Okay, so, pag joint method, analysis is per joint. Draw the free body diagram, apply the equations of static equilibrium. Ang method of section, kung ano yung tinatanong ng member, doon pa rin lang magpuputol. Incidentally, the rule is, you really have to cut the truss, separating the left from the right, and then select which one is easier to analyze. Kailangan putol talaga yung structure mo, yung truss. And then you will draw the free body diagram, solve for the unknown. Ang maganda sa section method is, kapag napakahaba ng truss, at ang tinatanong yung gitnang member, you don't have to go through the first joint, second, and etc. Kasi kung joint method, hindi ka makakarating doon without solving the first joint. So, ang tagal bago makarating doon. So, meaning, section method is shortcut. Okay? Illustration again, just to recall, method of joint. Method of determining the force or stress developed in a truss member by analyzing per joint, starting with the joint having only 2 unknown members in a equation. Ito yung sabi natin. Okay, so for example, at joint A, i-separate mo yung joint na yan. Ito na yun. Draw the free body diagram. Ano yun? The force applied and then the forces that are developed in the members of the trusses. Assume tension, no problem. Okay, kapag negative yan, it means that the assume direction is wrong. Okay, so I think okay na to. Other parts of your structures na kung saan medyo napakarami ng members mo, kagaya nito, dami. So may force ka doon kasi may load. May force ka dito, dalawa to kasi meron kang dalawang members na putol at saka yung incline. So in this case, I cannot compute this unless I solve this first. Kailangan alam ko yung ito, at least ito, tsaka yun. O kaya, dito. Kasi pwede dito nagsimula, punta ka roon, tapos ito, alam mo na itong dalawa. Pwede ka nang pumunta dyan. Anong dalawa na lang. Laging dapat dalawa ang unknown mo. And you can have 2 equation to it. Never mind the computation, forget. Okay, inulit na, section method is a method of determining the bar forces or stresses at any desired member of the truss by passing a cutting plane at the desired member. Draw the FBD and analyze either the left or right part of the cutting plane using equation of static equilibrium. That's it. So, illustration of section method. Halimbawa, ito lang ang ating tinutukoy. O, hindi cut mo yan. Incidentally, you will be able to cut the entire truss. This is the free body diagram. Prolong the lines of action of the forces here. You can sum up moment about E, then you can compute for the desired member. O kaya kung ito naman tinatanong, then doon ka mag-moment. And then after computing for the 2, you can just sum up forces along the way, compute mo na rin yan. So, it's simple. What is the instrument used to measure velocity and acceleration of an earthquake? Seismograph. This is an illustration. Balikan ko, bakit hindi ko pinili ang accelegraph? Because this is the rule of accelegraph. Para sa earthquake motion in where? In dams. Okay, so, ito yun kasi in general, sa building. The term in working stress refers to reinforced concrete beam in which the cross-sectional areas of concrete and steel are of such dimension that it develops its full allowable stress simultaneously. Balanced design. This is the perfect design. Okay, kaya lang, mayroon kang under-reinforced, over-reinforced. Kapag ka, kunyari, ang perfect design, sobrang balance talaga yung compression sa tension. Sobrang balance. In the event na lumiit konti yung cross-sectional area ng bakal mo kaysa sa concrete, ang tawag doon under-reinforced. Kapag over naman, mas marami yung capacity ng bakal mo kaysa doon sa kailangan. Over yun. Between the two, sabi natin, these are considered evil. Between the two evils, according to code, you have to choose the lesser evil, which is under-reinforced. Bakit? Kasi kapag under-reinforced, nag-yield na muna steel, saka pa lang nagka-crack yung concrete. So, ano naman, pag nag-yield ng steel agad, nag-crack si concrete, medyo makikita mo na may bubukad dyan, meron kang warning. Ang tawag nito is running time. Run for your life. Pero yung over-enforced, mas marami kasing bakal, na durog na yung ano mo, konkreto mo, pagbagsak niya, hindi naman matitira yung ano eh. Bakal eh, sama-sama din yun eh. Kaya, the code defines this as abrupt collapse. Delikado, wala kang warning. Which is the best volume and why? Ito na yung kanina. Which is the best volume and why? Circular. Ito na yung ano. Na-explain ko na kanina. Sa bakal pa lang talo na yung type volume, yung square or rectangular. Whether square or rectangular, type volume yung dalawang yan. Minimum bakal is 416. Samantang circular, 6 agad. Okay, wala nang triangular volume, kayo naman nag-design yan. O kayo naman nag-design. Yan, sa mga style, you can just, gaya ng mga ano, yung mga type volume minsan eh. Kaya sa Shangri-La, ano, yung mga design ng volume din, binalutan lang ng metal na gano'n para magmukhang beautiful. Ayan. Okay, illustration. Ito ka lang, meron ako nakita ulit. Ito ay hindi 16 ito. Correction 416 mm. 616 mm. Ay, lagyan ko na ako, sorry. Yung, nawala. Good. So, okay, so 16 na yan. Next. In addition to that, bigyan naman natin ng credit yung iba pa. Very quickly, circular section can use spinal types of stirrups which is more effective compared to square-shaped stirrups. So circular section will have higher column compression capacity compared to square section with the same stirrups ratio. It is also easier to strengthen in the future. Circular section will have same moment capacity or direction. If the section area is equivalent with square section, the moment capacity will almost be the same. Where seismic source can be estimated accurately, and thus the direction of the long distance earthquake can be predicted accurately, the use of rectangular section will with longer side parallel to the earthquake direction may be more effective. Pero paano malalaman yung direction of earthquake? If only if you can find, if the source of earthquake is near, the vibration will come from random direction. So the use of circular, nakita nyo na. So this is in favor of circular pa rin kasi kahit saan direction, uubra. Ito naman, for small buildings, ayun, ito yung mga tinitira natin sa nawala ng kailangan ano. Tayo lalo na. Ano tayo ng mga houses, residential houses, minsan without the structural design. Ano na lang, joke lang pero yun. Dati ko mga estudyante, kumakan ng mga building na ano, ng mga structure, dito, residential. Sabi ko, uy, mag-share ka ng blessing. Magtatanong lang tatanong na yung column ko, okay ba ito? Bakal. No problem, text lang, libre. Because circular, look at this requires large open space. The use of L-shaped columns will be better than circular. Saan? For small buildings or houses, requires large open space. Okay, so this is important in your practice. Study wind, study lang naman. Okay. From the wind load, from the word. Alam mo naman na nanggaling ko sa wind. Dynamic load, wind load is a dynamic load. What else? Even the earthquake is dynamic load. Di ba? Lateral load is horizontal load. Seismic load is earthquake load. Yun na. Kaya lang, when it comes to wind load, there are many factors that affect it. So wind load, dynamic load, yan mga galing sa mga definition na rin. Ito yung factors affecting wind loads. Wind zone location. Saan ka ba? Saan ba yung lugar mo? Nasa zone 1 ba? Zone 2? Zone 3? Tatlong zone siya. And then, what kind of facilities? What do you plan to build? Is it essential facilities? Hazardous facilities? Is it standard? So, kasi from there, you will see the wind importance factor. What exposure do you have? I mean, will you build your building? Is it exposure A, B, C, D? Apat. Okay, so, what is the height of your building? Is it high rise? Low rise? Or just, alam mo yun, one story? What? Other factors, marami pang iba, but these are the very, very critical. So, wind zone. Taken from NSCP, zone 1, 2, and 3, look at the line, heavy line. Kita mo yung itong strip na to dito, kasama din yung part ng Cagayan, Aurora, Quezon, part ng Bicol, tsaka Bisaya. Ayan, zone 1. What is the wind velocity? 250 kilometers per hour. Ano yung what are the places belonging to zone 1? Ayan, tingnan nyo. Sa amin, sa Albay. Ito pa. Na kung saan, kung dalawin ng bagyo, talaga namang bongga. Kapag nasa zone 2 ka naman, here. What is the wind velocity? 200 kilometers per hour. Ang zone 3, 150 na lang. 150 na lang. So bakit? Kasi normally nagagaling sa east ang bagyo. Yung mga NPAs naririyan. Tapos pag naging bagyo na, ito, it's either towards that direction, towards this direction. Basta ito lagi sa pool. So dito sa zone 2, lumiit na yan kasi naharang na ng iba ditong bundok. Lalong naharang na, dito kaya lumiit pa dito. Kaya lang, maiba lang akong konti, parang laging nasa yellow or orange alert ang Palawan ngayon. Ito yung lugar na kahit summer, muulan. Pero wala siya fault line. Pero ito yung open sea. Kaya parati siyang, never mind. Basta ito yung pagpipilian mo kung saan lugar. Para kung nasa boundary ka, piliin mo yung mas malaki. Kasi para safe ka. Ito yung sinasabi ko, wind importance factor. Naku, hindi ko na bago ito ba? Same hindi nagbago ito sa 2015 edition. Essential facilities, 1.15. Kapag hazardous, ito. Kapag special, ito. Standard, miscellaneous. Ito yung canopies at saka yung yung fence. Fence that is 1.5 meters and above. So, iba-iba. Tingnan nyo naman. Sa bagay, ito magkakamukha. For standard, it's only 1. Ito naman, 0.97. Kaya, better know it. Kunti lang naman yun Never mind, this just showing you that yung ating wind, ang direction talagang turbulent. Pero yung pinaka-maximum horizontal force or lateral force is the maximum that we apply to our building. Pero sa bubong natin, dalawa sa bagay. If the force tends to lift your roofing, ang tawag dyan ay suction. But if it tries to push the roofing, we call it pressure. Pressure or suction. Pareho lang naman load dyan eh. Naranasan nyo yung parang gustong buhatin ng bubong nyo, yun na yun, suction yun. Pero minsan naman parang dinidiinan, pressure. And ito naman hydro, water. Effect of water, ganun pa rin horizontal. Habang lumalalim ka, lumalaki ang pressure. Parang lupa, habang lumalalim, lumalaki yung soil pressure. Ito pa rin, no? Wind loads. Para ASCE naman to. Basic wind speed, directional factor, importance factor, in exposure. Banggitin ko nga yung mga exposure nito. May exposure tayo A to B. D pala. Exposure A is like Metro Manila, heavily dense city, maraming tall buildings. Okay? So, kung di na lang marami pa lang kakarang. If you plan to build also a building, okay, medyo okay kasi marami ng building na kakarang ng wind. Pero kapag exposure B ka, lumabas na sa Metro Manila. May mga mangilang-ilang buildings na tall. We're talking about tall buildings yan, meaning high-rise. Maybe nasa Laguna ka na. Konti pa lang, mangilang-ilang pa lang ang mga tall buildings, Cavite, gano'n. Pero kapag exposure C ka, agricultural land naman. Nueva Ecija is very plain naman. Okay. So, kapag wala man nakakarang sa amin, kung mag-build ka ng sa structure doon sa mga bandang kalayan, baka ikaw pa lang yung kakarang doon sa mga tatabi pa lang sa yung building. Pag exposure din naman, near bodies of water like seas and ocean, up to 2 kilometers from the shoreline. So, yung within 2 kilometers na yan, balak mong mag-put up ng resort, o balak mong mag-bigay ng hotel, ay mag-design tayo ng proper design kasi pinakamalakas ang wind doon. Okay, exposure A, B, C, D. Alright. Topographic factor also, gas effect factor, enclosure classification, internal, etc. But these are actually big deal in our design. For your, para sa inyo, hindi na siguro, maybe just the formula. This is just the wind pressure, wind load. There's a lot of things to know. Anyway, habang tumataas sa building, lumalaki yung wind. Ito naman, seismic kasi. So we're talking about earthquake. Kung may wind factor ka, meron naman seismic importance factor. Depende pa rin kung anong facility mo. Essential, hazardous, so ito naman. Okay, so just look at the difference between this. Ito naman sa kabayo. Ito ay accepted also from the NSCP. Makita mo napadtad tayo ng fault lines. Ang wala lang itong alawan. Pero ganun pa man, ito ay only one of the pages in NSCP. Mga lang to yun. Table 2, so therefore this is in chapter 2 lang. Buklatin nyo ang PDF nito, download po ng libre. Kaya you still have time to look into this. Yung sinasabi nilang Maritina fault line na gumagapag ng Pasig. Pagparin natin na hindi maganap yung big one na tinatawag nila. Kasi pag nangyari yun, baka mabunan sa mapa, kawawa kami, kapitbahay ko lang yun. Okay, additional fault lines. So do we know exactly where they are? Yes. Hindi lang pupunta ka sa kundi punta ka sa box mismo, sa pag-asa mismo, para malaman mo yung ibibigay sa iyo. There is what we call, in the pre-engineering design, we conduct this geological and geotechnical investigation. So doon natin natutuklasan na, nandito yung fault line. Kung hindi mo iwasan, hindi, wag mo na lang itapat doon sa fault line, mga poste, yung mga pier. Okay, this is also showing us the lateral effect of the load, wind load, or earthquake. So itong pwede mangyari sa building mo, at kung mangyari yan, tingnan mo naman yung foundation mo. So pwede ikagiba, ito kaya we make sure that our structure is strong, capable of carrying the load, including the foundation. Okay, never mind. Given the length of a bar, what is the weight? Give example. Kasi kung titingnan ko lang to, walang information na binigay. Pero ang linaw, kung given a bar, length of a bar, what is the weight? I would like to think this is not chocolate bar. Kasi structural tayo, maybe steel bar yan. Tama? So if it is a steel bar, mag-assume lang tayo ng anong diameter kaya? What is the length kaya? Can you imagine? O sige, magbigay tayo na lang. But before that, may I remind you this? Kung kinakailang i-memorya. Ito yung basic mass density ng steel. Okay? Mass density of steel, weight density of steel, in kilonewton per cubic meter, and newton per cubic meter, and this is in English naman, pound per cubic foot. So, how do you know this? From the formula, weight equals mg, mass times gravity. Acceleration to gravity is constant, 9.91. So, if the mass is known, 7,850 times 9.91, this is the result. Mas tinatanggalin mo yung 8.5 din, 77,000, okay pa yun. Ito na. So, 1 kilogram, what happened to the unit? Kilogram per cubic meter equals meter per second square. Ito, tinanggal natin yung 1 kilogram saka meter per second square. Ito pinag-combine. Naging newton siya. Kaya newton per cubic. Please take note of this kasi ito binigay din sa exam yun, yung conversion. So, well, if you divide this by 1,000, this gives us 77 kilonewton per cubic meter. Now, what if I want to know the equivalent English unit? I go back to 750. Ito naman, 1 kilogram plus 2.2 pounds. 1 meter, 3.28 feet. Diba? Cube. Raised to the cube. Bakit? Ito, exponent to because this is cube. So, this is the result. This is now rounded to easier to memorize. Pounds per cubic foot or PCF. Same. With this, well, this is just to give you idea how we come up with this figures. Tingnan natin, given a length of bar, what's the weight? Mag-assume tayo. Ayan. Ano bang weight? Is it in kilogram, in kilonewton, in newton, or in pound? O, diba? So, for 1 meter length, i-multiply mo ng 1 meter, ito yung magiging result. Ngayon, kung gusto mo pang malaman yung equivalent weight in kilogram only, you should know the diameter. Kasi yung cross-sectional area mo, ito natitira na to, cross-sectional area yan. So, if it is 8, number 8 bar, that's 25 millimeters. Ano yung area mo? Pi d square over 4. Ang diameter mo ay 0.025 para maging meter. O hindi multiply mo na, makukuha mo na yung weight in kilogram. If it's in kilonewton, use this. Okay, for 1 foot, kapag English naman, kasi labo, walang biligay, ito ngayon, kasi for 1 foot, ay matatanggal yung isang foot, di ba, sa unit. So, ang kailangan mo lang area, cross-sectional area, don't forget the formula, pi d square over 4. What is the weight of 1 by 1 steel cube? Huwag kayong magalala, mga abul-abul ng lecture na yan. Kanya-kanya yung stock knowledge. Trust your intelligence. Kami dito, naka-assist lang. Alam niyo na yan. Sige, makulit lang ako kasi naku, hindi ako tunin yan. What is the weight of 1 foot by 1 foot steel cube? O hindi, ano yan, English, kaya ito na yung gamitin natin. O di, 490 pounds dahil 1 by 1 by 1 cube eh. Okay, so madali naman ano? Kaya, you can imagine now, if you are given a beam, and then meron kang bakal sa beam na yan, kailangan mong computein ang length. Kung may mga balok kinisama mo, kunyari, isa lang pirasong pinapa-compute yung weight. O hindi, alam mo yung size niya, tapos alam mo yung total weight niya, kasi naman kailangan mo sa formula. Yun lang. Weight of lightweight aggregate in kilogram per cubic meter is? Okay. So, 1120 kilogram per cubic meter from NSCP. In another exam, naglagay lang ng structural weight o. Ulit. Lightweight aggregate ngayon, naglagay ng structural. Pareho lang. Next. Study flange, web, gusset plate, base plate. So, syempre, illustration ulit. Alam natin yung flange, kanina pa natin napag-usapan. Resist shear, di ba? Moments. Ang web, resist what? Shear. Okay, ang splice naman ito. Dugtungan, kapag kulang yung length ng bar mo, hindi magdugtong ka, but you need to provide lap joint splice. So, meron tayong computation dito. The fastest to compute is 40 times the diameter of the bar para malaman mo yung lap joint. Gusset plate naman, ito pala yung sinasabi ko kanina. 40 times the diameter of the bar. So, ito, kung hindi mo kayang mag-splice, ay mag-coupling ka kapag napakatataba ng bakal mo. Okay? Next, ito na ngayon yung gusset plate. Para ito na, pakita natin kanina, to connect what? The web members to the bottom cord. This is one way to do it by providing gusset plate. Dowel naman, these are bars that you try to extend para sa mga darating pang new concrete to be poured. So this will improve the bond between the old and the new concrete. Parang ganito. Okay? So base plate, ito yun, base plate. Okay, base plate. We call it a plate this time, but this is steel plate. Minimum splice when you join 16 diameter bar, o hindi multiply mo na yung 40 by the diameter of the bar. 40 minimum. Kung binigay ang strength ng material mo, o hindi, ito English to, inches. Kapag number 3 bar, ayan. Paano yan? I-memorize mo ba? Siguro, hindi na. Pinapakita ko lang sa inyo na, kapag practitioner ka na, kailangan mo ng yung kopya, para hindi ka na nagko-compute pa. Meron ng standard given to us. But it is impossible for you to memorize on tables. I don't know. Kasi ako mahina ako sa ganyan. Pag gusto ko pang mag-compute, kasi mag-memorize, baka magkamali ako ng pag-memory in. Alam mo yun? But this is so tedious if you pre-compute. You will really compute, but alam mo yun, naka-specific kung anong strength. Okay? So, abangan na lang siguro, kapag practitioner na kayo, meron na kayong babasahan. Minimum splice when you join 12 and 16. I'll compute using 16 para safe sa 16, safe din sa 12. The distance between two zero moment compression member is effective length. Between 2 points of zero moment, yun ang pinaka-effective din. This can be shown, effective, nagkakataon lang na yung length mo is effective length na rin coming from the supports. Bakit nilagay dito yung yung K? What is this? This is taken from slenderness ratio of column. So, KL over R. Slenderness is KL over R. If it is simple supports, K equals 1, kaya L over R na lang. Ano yung L? Ito yung L. Unsupported din. So, mula lang dito sa support hanggang doon. Huwag mo isama yung inch. Okay? So, ano yung R? Radius of gyration. It is the length of embedded reinforcement including pre-stressing stand required to develop the strength of the reinforcement of the critical section, development length. So, this is the formula in getting the development length. So, medyo tedious. It needs a lot of computation here. But, according to code, the minimum LD is also equal to 40 times the diameter of the bar. Okay? So, ito yung definition taken from NSCP. Ito yung kanyang isa pang purpose. Transfer the load from steel to concrete. Development length is also known as anchorage length. So, this is now the one given in the exam, which is taken from the NSCP. So, ang kapatid niya, pinsang buo, embedment length is the length of embedded reinforcement provided beyond the critical section. Itong development length at the critical section. This is beyond. So, ibig sabihin, may development length ka na, may embedment length ka pa ba na needed? Sometimes, yes. If needed. So, there are two drawings here. Let's talk about the wrong one muna. Ang beam, when we design, we have to design also the bakal. Yan ang bakal. And then, when we design the column, it has its own set of bars, correct? Pero kapag sa construction hindi po pwedeng yung bakal mo dito sa column, sa beam, wala silang relasyon. So, even in the plans, we prepare connections. Ito yun. For example, the top bar coming from the beam is now bent. Yun. The bottom bar is also bent towards this. Ito tamang-tama kasi end na ito ng beam mo. At saka last column ito. Kaya binensyonan, nagkataon ito na rin yung development length niya. Pero kung may beam ka pa doon, hindi tuloy mo lang. Tuloy mo lang. Although pwede nang mag-bend ka na para mas matibay yung kapit nito doon. So if there is another here, hindi isa pa. Sa kabila mo naman gawin. Yan. Dito naman. So, look into this. Kapag ganito yung drawing lang, this is not acceptable. Only this is acceptable. It is the length of embedment, reinforcement provided beyond the critical section. Nakita na kanina natin yun. Embedment. How is a 90-degree bend standard hook for concrete reinforcement constructed? Provided 90-degree bend plus 12. Di ba kanina yung beam? Sabi ko, yung beam kanina nakabarok to ganun. 90-degree bend yun. So, you will provide an extension length of 12 times the diameter of the bar. Ito yun, 12. Pero kung U-turn, ganitong ito is only 4 times the diameter of the bar. Ito yung sa stirrups, 6 times the diameter of the bar. Okay? Which is true about lap length and development length? They are the same in terms of minimum requirement. They are the same in terms of minimum requirement. Dagdagan lang natin yung splice natin, kaya nagiging equal to the development length kasi we are talking about the class A splice. So LD, whatever LD is, times 1 lang. Pero kapag class B, alam mo yun, parang concrete ba? May class A mix ka, may class B. Alam mo naman ang class A is the best, better mix proportion than B. Ganun din dito. Class A splice is much better than splice B. Meaning, ito, times 1 mo, ganun pa rin. Kaya yung nagiging splice natin ay parang equal to the development length. But don't forget the code. So, for 16 bar, lap is 40 times 16. LD is also same. Just to emphasize, you can use this. Even in the actual design, pinapakita lang natin that the development is 40 times the diameter of the bar. Proof. From the figure above, the maximum tensile stress is at the point what? Doon, syempre. Kasi doon ang sobrang nabaluktot, sobrang nabend. So, kahit paano yun ang super stress. Next. From the figure above, LAB is what? Development length. Okay. So, kung walang development length, embedment length na ang sasagot nyo. Kung walang development length, embedment length. Okay? Sample basic computation of lap lengths using different situation. Ito na lang, huwag na kayong lumayo. Kasi parang hindi na magkalituhan. Napakita natin yung mga computation like 40 times the diameter of the bar only. Study lift slab construction. Ito yun. Lift slab construction is a method of constructing concrete buildings by casting the floor or roof slab on top of the previous slab and then raising the slab up with hydraulic jack so being cheaper and faster it does not need forms and shores. So para lang ito sa mga precast, di ba? As in, lift slab is laying of the slab on the next elevation. Yun lang. So lift slab construction can be more economical than conventional construction when the building is vertically uniform, such as for hotels, apartments, dormitories. Ayan. Siyempre, hindi naman lahat kasi ng slab puro precast. So hindi lahat uubra ang lift slab. Meron tayong cast in place, okay? Lalo na if the slab is to be poured together with the steel, same. Excuse me. Na iba lang dito, tilt talaga tilt. So, same, precast walls that you need to install at site. Ayan, pinapakita natin sa atin kung anong mga heavy equipment that you need, etc. So, it's just installation. The proper methodology for installing precast walls. What's this? Distance between two image ports. Parang nabanggit natin kanina, no? Clear spot. At nag-compute pa tayo. So, pag sinabi natin center to center, design length ang tawag natin doon. When we design, we consider the entire length. Magiging safe ang ating design. Purlins are used to prevent what type of tension? I rephrased it because something's wrong with the if the question, what type of stress or force does a purlin support? The answer is flexural stress. O kaya, it prevents what? Hindi pa rin type of tension, specific yung tension eh. Diba? So, ano yung purpose ng purlin? It actually supports the roofing materials. And then, syempre, where the wind load and other loads are acting directly, and then transfers the load to the rafter or to the truss. So, yun ang purpose niya. Well, as to what it prevents, siguro, not to prevent, but what it carries. So, ayusin na lang ha. Basta tinanong ito, anything that is about purlin, alamin nyo na. The most important factor affecting the strength of concrete is water-cement ratio. Kung talagang walang water-cement ratio, my answer is water because pwede natin pag-usapan yung water-cement ratio from 0.3 to 0.6 from professional engineering, na international by McCormack, 0.3 to 0.6. Pero sa atin sa typical grades, allowed naman ng 0.7. Ano meaning ng mga decimal ngayon? In terms of fraction, 0.3 is 3 over 10. 0.4, 4 over 10, 5 over 10, 6 over 10, 7 over 10. So yung lahat ng numerator, lahat yun ay water. Water, cement. Meaning, yung nasa ilalim na lahat yun ay constant ba? Para sa ating water cement ratio. Cement yun. So water, cement. Numerator, denominator. So therefore, habang lumalaki yung water mo, hindi lumalaki din yung water cement ratio. Pwede imagine, 0.3 or 3 over 10, 4 over 10, 5 over 10. Diba? So from there, you will notice that as you increase the amount of water, lumalaki din yung water cement ratio. O ano naman? As you increase the water cement ratio, as you increase it, nag-result to a less strong concrete. Parang sinasabi natin na, the more water, the weaker. O ulit, the more water, the weaker would be your concrete. The lesser water, the stronger. Ganun lang yun. Okay? Ito yung sinasabi para nino. So, kita nyo naman yung numerator, nagbabago din yung tubig. Ito yung constant. So you will see na, as you increase the amount of water, lumalaki din syempre result ng inyong water cement ratio. Water, volume, cement, constant. The less water, the better the quality, the stronger. Nabigyan natin ang discussion with this using one mixed proportion. Dahil kasi, tinanong ito the question in the board exam was, what is the part of concrete which occupies more than 75% of the concrete volume? Yun ang tanong. So, alam natin. Okay, alam naman natin yung cement. 1 bag of cement is 1 cubic foot. 2 cubic feet of sand. 4 cubic feet of gravel. Lahat cubic feet. 1 bag is 1 cubic foot. 2 cubic feet, 4 cubic feet. But there are 7 in all. Kunin natin ang percentage ng bawat isa. Yan na. Okay? So kung grabe lang pinag-uusapan, 57% lang. It will not answer the question. It occupies more than 75%. Kaya, hindi rin pwedeng sand. Mas maliit. But if you add the 2, nagka-qualify siya. So this is 85.7%. Ito lang ang pwedeng mag-qualify sa tanong na what part of your structural ingredient that occupies more than 75% of the concrete volume aggregates. Kasi ito yung isa na sa mga choices. Okay? So, ano ngayon yung ano? May tubig ba dyan? Wala. Kahit anong dyan maninigas, ano? So we have to provide water. We'll talk about the amount of water, but I give you na the average 6.5 gallons per bag of cement. So kung may 1 bag of cement ka, meron kang graba dyan, meron kang buhangin. Automatic yan magkakasama. Okay? So, class A pa lang yan. Paano kung class B? Pag lalong lalaki ito kasi magiging 2.5, ito magiging 5, tama? Lalong lalaki yung aggregate mo. So we chose this. Ito yung katubigan na. Kapag 40 bagger, yun lang naman ang meron tayo sa Pilipinas. Ito ngayon, 16 to 24 liters of water. 16 to 24, so may range ka. Anyway, kung depende sa iyo, tingnan mo. Pero, sa atin kasi 40 kilogram bag lang naman tayo. Kung may 50, dito ka pumili. Meron pa. Ano? Ito yung mga water cement ratio nyo. Tingnan nyo ha. Ito 0.55, 300. Doon na tayo sa extreme. 0.4, 360. Habang lumalaki yung water cement ratio, malaki ito, maliit yan. Maliit ito, malaki. Inversely proportional. The more water, the weaker. Yun ang meaning ha. Yan. Okay, ito yung sinasabi ko nina. So, they usually varies from 5 to 7 with 6.5 gallons as average for ordinary job condition. Okay? So, 6.5 gallons per bag. So, para hindi na kayo mahirapan. This is another proof. Tingnan mo yung water cement ratio dito, maximum water cement or water cement ratio. Kung 7 siya, 2,000 lang. Samantala kung 5, 3, 7. The more, the weaker. The less, the stronger. A complete record of tests of materials and of concrete shall be available for inspection during concrete of work and for how many years after completion of project you should keep it. Within 2 years, minimum. Pero, I just want to tell you that in offices where we have library, where we can keep now e-files, diba? We keep it until the warranty period of building. Ako for one, I keep for as long as I can. Hanggat hindi natatapos yung warranty nangamba ka kasi baka may reklamo in the end. Diba? Anong papakita mo ngayon na ebidensya kung wala kang record? So you keep your record. Who is responsible for keeping and maintaining complete record of tests? My choice is project manager or owner and dapat N. Bakit? A project manager could be engineer or architect. Pero, you can compute, you can keep. You be responsible to have the record. Pero kung isang project mo, you keep a lot of records, wag ko lang kung ito makilo, pero I try to keep for myself. When I was younger, lalo na ako naipit sa sarili ko kasi baka meron, Diyos wala namang material. But now that I am in this position, I keep, and then we have in office, parang meron tayong server, di ba? Where we keep the records also for everybody's consumption. Pero meron kaming library to keep all records until such time, hindi na siya kailangan. Nung hindi pa uso yung e-file, talagang mga plano, as in, mga hard copy, may sa kang lagyan yan. Pagkaraan ng 10 years, deliver mo na sa archive. Yun. Pero ngayon, mas madali kasi pwedeng i-file. Minimum and maximum space of lateral ties, ito na yung sagot. You need to compute. Sabi nga ng code, magliliit sa 25. Pero huwag ka basta ka lang maglagay 25, mapapamahay ka. Mag-compute ka muna. Choose the list of the following. What is the diameter of the bar times 16? Ang S mo dapat less than that. O kaya less than 48 times the diameter of the lateral tie. Okay? Or less dimension. So tayo nakakatulong sa less dimension because if the minimum area required for column is 65,000 or 60,000 square millimeter, take the square root of 60,000, that gives you 250. So dapat ang least dimension of column 250. Pero nag-give way tayo sa request ng architect, kaya pumapayat na 200. 200 wala pa yung palitada nun. Wala yung plaster. Okay, so this means if we are to go back to the standard which is, maski 9 nga 9 inches is 225. Kaya bumibigay tayo sa 200. Total ang minimum naman ay 9 inches. This is it. Ay, hindi pa pala yun. But anyway, compute mo lahat, whichever is the shortest or the smallest, yun ang gagawin mo. Okay? So, they must be greater than a little bit. Huwag kang kapag ang computation mo lumit dito, ipatay ka na. Hindi pa pwede yun. Based on the figure shown above, what's the total length of the lateral ties considering a minimum concrete cover for non-precise 300 by 300? Computation of length tayo ha. Answer is, bago yun pala. Balikan natin. Ito yun Ito yung anchorage. Yun. So, ito na ngayon yun. So, we need to add 6 times the diameter of the bar. O, ito na ngayon. Non-precise naman, no information if this is in contact with the ground or exposed to weather. Assume natin na hindi na lang. Nabubukan siya. So, over the 40 sa isang side, therefore, 220 na lang. Bakit? 300 kanina minus 80. A square siya, so 220 by 220. Therefore, the length of your stirrup surrounding only ito, yung perimeter lang, 220 times 4. 220 plus 220 plus 220 plus 220. Plus, itong extension, dalawa. What is it again? 6 times the diameter of the bar. 6 times 10, kasi 10 diameter yun, no? 10 before bar yung 10 millimeter. Multiply ko na ng 2 kasi dalawa nga, oh. So, the answer is 1,000. Kaya ang sagot ay 1,000. Okay, ganun lang. The belts can be found in beams, stirrups. Sa column, yun ang ties. Ties are used for what type of structural element? Kanina pa yan, column. What's the purpose of stirrups aside from resisting vertical and diagonal tension? Hold the main bars in place. Structural system. Without a complete vertical load bearing straight frame, wall system, bearing wall system. And it is an essentially vertical truss system of the concentric or eccentric type that is provided to resist lateral forces, raised frame. Example. Minimum thickness for load bearing walls, 200. Pag non-load bearing, 100 to 150. 100, yung mga D4 ba? Na CHT. Ito. Taken from a book. Ito yung block natin, 20 cm, which is 200 mm. Para sa stabilized or thickness. But these are the other. Ito naman, sa interior wall, kapag maliliit, 10 to 15, proof that you can use 10 or 100 mm to 150 mm kung non-load bearing. Pero kapag load bearing, 200. Why do we provide vertical and horizontal reinforcement for CHB walls? Kasi pwede siya magkaroon din ng pagbaluktot. We need to provide, just in case there is a possibility of deflection of the wall, i-resist niya yung possible buckling. What is the difference between post-tensioning and pre-tensioning? This is the definition. Post-tensioning, application of tensile force to the tendons after the concrete has hardened. Pre-tensioning, application of tensile force to the tendons before concrete is poured. Never mind, this is this procedure. Procedure pa rin. Kaya ko ito sinama, the idea of this is, kapag nilagay mo lang yung tendon in this manner, pag hinatak mo, itutulak niya yung beam pataas yung concrete, na kahit papano it will create camber, kahit sa principle lamang. Hindi siya actual, hindi niya babalutin yung joint. But after stretching the tendon, mahirapan din na stretch siya. So, pag niloaded mo, hindi na siya mababaliktod. No more deflection. Ordinary design, because of the load, the bridge may deflect. So, dahil na-deflect, the tension part will crack. Pag naglagay ka ngayon ng bakal, titibay siya, lalo na kung pre-stress siya. Kapag pre-stress siya, you will, if you compare the conventional with the pre-stress, makikita mo na yung ating tendons, mga special, bakal, very strong. Okay? Ang stress niya ay napakalaki. Ang naman ito, ang consequence is that you can use longer spans. Ito, limited ang span mo. Mali-design naman eh. Ordinary ito yung conventional method. Sa pre-stress, can you see the arrow? You can use longer span with the same size of your structure. Sample of tendons. Okay, sample din. At kung paano, ito yung wala pa. Anyway. Built-up section of beams and columns, built up. Mga 2 or more same materials combined together. Oras na they are the same material. So, kung ito yung plate, steel pa rin yan, steel pa rin ito. Maraming pinagsama-sama, made of the same material, built up. But if they are made of different materials, composite ang tawag. Built up pa rin. Built up. Next. A transforming bond is considered dead load because it is permanent. You cannot transfer it from one place to another. From the given illustration, identify double fillet weld. We were not provided a drawing, but I provided this. Ito yung, sa mga types of welding, ito naman ang favorite ng inyong examiner, yung fillet weld. Ito yung symbol. Pag may nakita kang ganito, with the number, ito yung arrow na to, symbolizes that there is only one part to be welded, and this is the size. Pagka-double na yan, kita nyo parang dalawang kapsulok with the same number there, means two sides will be welded, same size, same number. Okay, same pa rin. Okay, both sides, magkaibang number, magkaiba yung sukat. Ibig sabihin, one versus the other. So, look here. Okay, so, ito lang. Ito lang yung tatandaan natin kung paano i-interpret yung mga yan sa fillet weld. Ito daw, meaning dalawa. So, dalawa eh. So, both sides. Isa lang. So, ito lang. Which is dangerous? Siyempre, shear wall with many openings. Where do shear walls rest? Footing. It is a wall designed to resist lateral forces prior to the plane of wall. Shear wall. I illustrated this a while ago. Study NSAP terminologies. Ibig sabihin niya, more terms. So, did you know that all the terms that I have already presented to you came from NSAP? Kaya, ito yung tip ko na lang. Puntahan nyo yung bawat end and beginning ng bawat chapter, may mga terms kayo doon. May definition of terms. Meaning, matutuklasan nyo na karamihan doon ay mga exam, nanggaling lang doon. It is one, mas ito. It is one in which the lateral stiffness is less than 70% of the stiffness of the story above. Soft. Madaling tandaan, stiff versus soft. Opposite sila. May kapatid yan. But wait, pag sinabi natin soft story, alam niyo naman na hindi siya kasing tibay ng iba. This particular story is hindi kasing tibay ng iba. So, because generally it's open. So, ang payat-payat ng mga support, kaya the possibility, failure. Ito yung sinasabi ko. It is one in which the story strength less than 80% of the story above. Weak naman. Strong versus weak. Strong versus weak. Incidentally, pagka soft story, automatically weak yan. Okay? So automatically kapag soft story, weak yan. It is the lateral displacement of one level relative to the other level, above or below. Story drift. It is the story drift divided by the story height. A. Story drift ratio. Study pedestal pier in column. Ito yung pedestal. Upright compression member with the ratio of unsupported height to average least dimension not exceeding 3. But for tapered member, the least lateral dimension is the average of the top and bottom dimensions of the smaller side. One pier, solid support, designed to sustain vertical pressure, which are usually used in bridges. So, kahit na malaki yung poste natin sa building, column pa rin tawag natin. Pero pagdating natin dyan sa flyover, sa mga bridges, column pa rin naman yan. Pareho lang naman. Pero pier are basically larger. Okay? Columns. Ano nun? Ito, tingnan mo yung 3 na yan, computation dito. Member with the ratio of height to least lateral dimension equals 3 or greater. So, kapag ka less, pedestal, greater naman, yan, column, magkukompute ka. Kahit makataas pa ito, for as long as this carries like this, magsusupport, pedestal ang tawag. Okay, gawin na binigay na dati pa sa board exam. This particular project is under Volume 2 of NSCP. This is already horizontal construction. Okay, lagi natin sinasabi, Volume 1, NSCP. May Volume 2 yan, Roads and Bridges. So, ito yung tanong na, pinakita yung MRT7 yata yun, MRT7. Tapos, what do you call down the beam along the rail, along the, the EDSA, EDSA? The answer was, rail beam. Ito rin yun. This is not EDSA, but this is rail beam. Natanong na rin ng PRO, bakit anong susunod ito? Yung mga nakaganyan, coping beam, coping beam. Ito yung sinasabi kong coping beam. Yan. Ito yung sinasabi natin, pedestal and column with the bearing plate. Kompleto dito ha. Pedestal, column, bearing plate. Columns only. It is a visual warning of impending failure. Cracks. Failure of material due to repeated or continued stress. It is more visible and severe in material subjected to heat. The other definition of heat is ability of the particles to flow like fluid. Ulit. The ability of material particles to flow like fluid. Okay, ng plastic. Solid naman siya. Subukan mong initin. Pag di yan natunaw, it will flow like a fluid. Can it happen to steel? Yes. Namumold yan. Kaya, it can happen to concrete too. So, kaya lang kapag nagkaroon na ng trip ang concrete, it's either, syempre natutulog na siya. Naghihiwa-hiwalay na yung aggregates sa cement. Ito na, over-reinforced is more dangerous than under-reinforced. Syempre, under-reinforced is less dangerous than over-reinforced. A building collapses without any warning. How was the building designed? Over-reinforced. Collapsed without any warning. A gap between building elements that allows them to move with expansion due to change in temperature or moisture. Expansion gap. Minsan tawag natin dyan, expansion joint. Ito, example. Pwede naman, itong expansion gap. You can imagine, column, binuhusan separate with a slab. Meron ka ditong awang, meron kang space, which will be filled by filler. Ayun, so, expansion joint din yun. A gap between buildings that allow them to move during earthquake. Seismic gap. Yun bang, kung may twin tower ka, dapat the side sway must be computed. Kasi bawal yung, alam yun, pagkauntugan, no? Mababasag eh. We have to avoid this to happen. So, there must be enough gap by computing the side sway maximum at the upper part of the building. It is a phenomenon whereby soil substantially loses its strength, usually due to earthquake and acts like a fluid liquefaction. The reason why we need to provide a very strong foundation. If the soil is very soft somewhere, baka hindi lang uubra yung mat footing. Baka you need to provide piles. Yan ang pwedeng consequence ng liquefaction. From the figure, which one is more dangerous during earthquake? Rupture. Advantage of steel over concrete, its elasticity. Buckling, what is it? Bading. Buckling is the lateral bending. Lateral is horizontal. Only columns, buckle. Ang beam, we call it deflection. Nag-deflect din kasi ang column. The deflection is called buckling. Okay? Severe buckling is crippling. That is already a failure, considered failure kapag crippling na. Okay? So, pag buckling, for as long as it is tolerable. Okay yan. These are buckled columns pa rin. Bending, what is it? Di ba kanina pa natin pinag-usapan yan? Flexure. Bending is flexure or the deviation from the original position when the load is applied. Okay? So, deviation from the original horizontal position, meaning advance siya ng position. From horizontal, nag-move siya. Maximum allowable load, the largest load that can be applied to the structure without failure. Okay, so 8 more minutes before our break. What resists bending stress? Lahat yan. All the above. Bakit? Section modulus muna tayo. Okay, section modulus is I over C. I over C. Therefore, if you want to get the stress na, okay, bali, itong I over C na to, magiging ganito na. So since, as you increase this S, inversely proportional yan, as you increase this will be decreased. Ang hirap na dadalhin ng material mo, liliit kapag lalaki mo section modulus is the meaning. So it resists bending too. Because S has something to do with, pati mo to, H, B, ano yan, size ng, ano mo yan, ng biga, ng structure. F decreases as S increases. It's the meaning. What about rigidity? Yes. Rigid bodies do not deform under load. Sino may sabi? Ha? Jensen, Singer, and all authors. Engineering mechanics. What resist bending pa rin? Is it moment of inertia? Why yes? Because I equals VH cube over 12. Look here. The stress, the bending stress The stress is MC over I. If I is VH cube over 12, the bigger the I, the smaller the stress. So kung gusto mong ma-stress, ma-AD yan, liitan mo lang yung size mo ng inyong structure. Diba? So madaling tandaan, diba? Ayaw mong ma-stress masyado structure, laki mo yung size. Ganun lang siya. So, all the above ang sagot. The perpendicular distance of spanning member deviates from under transverse load, increasing with load and span, and decreasing with an increase in the moment of inertia of the section or the modulus velocity of the material. Ay, deflection pa rin. Hindi ba yung na-reprise, no? Pero deflection pa rin. Deviation from the original position, from the original horizontal position of the beam. These are the, kanina pinakita ko kanina pa, yung mga fixed-ended beams. Tingnan niyo to ha. Ito yung simply supported beam with uniform load. Kanina, fixed-ended with uniform load. Ano sabi ko? Kanina, sa fixed-ended, WL to the 4 over 384 EI. Ay, yung simply supported 5 times bigger. Kita nyo? So, if you can only recall what I said kanina, malalaman mo na, what if binigay yun? What if ito? Kasi ito nabigay na ng ilang beses eh. Paano kung yun naman ang maisipan? Kapag fixed-ended yan, ganitong senaryo, fixed-ended yan, tatanggalin mo lang yung 5, yun din ang formula. Okay? Bakit hindi pa tingnan ng iba? Kung pwede ibigay din. But anyway, I don't think this will be given kasi it's a bit complicated. Ito rin. So, itong dalawang to ang nanganganib itong beam with concentrated load in the middle. Ito, kasi fiber nila ito. Pangalawa, tatlo. What usually happens to steel in a slab or reinforced concrete beam if such member is about to collapse? Ha? Start muna. Kasi yung rupture, ano yun eh. About to collapse na siya. It's just about to collapse. Crack muna. Hindi naman pwedeng deflect kasi deflect hindi pa yan nag-collapse. So crack. Shear force yan that will tend to separate. So itong beam mo kapag nag-split ng ganito, we call it shear failure. So ito ngayon ang iwa. Itong yun, shear din. As compared with the tension at compressional stress results. These are a group of parallel reinforcing bars bundled in contact to act sa unit, limited to 4 bars in a bundle, enclosed by stirrups or ties, bundle bars. Ayan. Minimum to be bundle is 2, maximum is 4. May code din tayo. Code. Bars larger than 36mm diameter bar should not be bundled. Ano raw? Kapag mahigit na sa 36mm ang diameter mo, huwag ka nang mag-bundle. Ibig sabihin, mahirapan ka na dyan sa mga dugtungan. Ang tataba na yan. Okay, din pala yun. Bars larger than blank should not be bundled. 36. So, magbabundle ka lang up to 36 pwede. Okay? 4 reinforced concrete columns. What is the best position of non-spandrel column? Kung description ka nag-usapan, mas 4 of A. Ito yung pinakita ko kanina. Ito yung non-spandrel. Ito yung spandrel, ito non-spandrel. And reinforcement used to resist shear and torsion stresses in a structural member. Typically bars, either single leg or bent into LU or rectangular shapes, located perpendicular to or at an angle to longitudinal reinforcement, stirrups. Okay, pinahirapan, pero yan yun, stirrups. I reinforced concrete encased structural steel section, rolled or built up, or concrete filled steel section, used as a column where both steel and concrete work as a unit is composite. So, 2 or more materials that are combined together, yan, composite yan. Steel and concrete. Sample. Okay, next is familiarization with the plans. Questions like, anticipate nyo to sa plan reading. Ano yung reason why the footing in grade 1? Kasi dito naman tayo binigyan ng plano, pero may sagot siya dito. Adjacent to the property line. What column have the same size of reinforcement? Gusto kong isipin na yung column kasing size ng reinforcement. O alin dyan mga columns na magkakaparang ng reinforcement. So, ganun. What is the number of longitudinal reinforcement in the wall footing? Magko-compute ka. So, sukat lang. Kasi, kung walang sukat doon, scale ka. Okay, plan reading pa rin. Ito rin naman yun. Ito yung naisip ko sa una niyang what is the reason ito? Bakit iba? Kasi nasa property line daw. So, reason why, yung column niya nasa gilid, pwede naman kasing gitna, pero bakit may gigitna kung mas maganda sa gilid? Dahil ito yung property line na, can you imagine yung bahay mo? Yung space na yan, sayang. Dikit mo na diyan sa pader. Para hindi siya eyesore. So, ito yung mga combined footing, strap footing, rectangular footing, combined. Ito naman ay trapezoidal. Meron ba sa question about trapezoidal footing? Compute the volume daw of the trapezoidal footing. Dapat alam mo ito yun, ito. Kunyari, tawagin natin A. Ito ay A. This longer side, A. Ito naman, B. Ito naman, L. How do you get the area? A plus B, multiplied by L over 2. Again, A, ito, A plus B, multiplied by, ay, add mo, tapos multiply mo yung sum ng L over 2. Area pa lang yun. I-multiply mo ng thickness, volume na. So, your math is so cute. What is the minimum width of wall footing? 400. Minimum width. So, what about thickness? 0.2 naman. Okay, so, siguro, let's take muna a few minute break. Okay, makapunta. So, 2 to 3 balikan ba? 2 to 3 tayo. Bigla rin. Just a moment, ha? Ayun. Control 4. Ay ba? Ay naku. Ba't ako nagkakaganto? Wala naman akong hika.
Maliliit na.
Ayaw. Hindi na pag tumatanda.
Wala po.
Kondo ako eh. Kaya ako yung nag-taxi lang. Kaya ko ano sa anak ko. Pakikiparada.
Kasi hinahanap ko. Dito ko kailangan po.
Mas pagtabi na ako ngayon sa taxi, sanay na ako. Pagpunta pala mamaya doon.
Silagyan ko sa Kuya Ray kung pwede ihatid ka na.
Ay, meron ng kakatid. Ay, thank you.
Silagyan ko.
Sige, salamat. Pero kung ano, pwede naman ako mag-taxi kaya lang. Kalimutan ko na saan doon. Anong floor?
Ah, sige, magkakalit sa Kuya
Oo.
Ray.
One pa naman. Okay, I'm back, guys. Shout out sa inyo lahat. Ay, talaga. Naku, alam mo, ito mga batang to, nakakapagselos na. Ang pinag-uusapan nila, hindi naman structural.
Feeling din lang.
Grabe sila, oh. Ang hard mo sa akin. Why are you like that? Oh, i-design. Ano ko, ano pinag-usapan? Bahala kayo. Pag nagtangko ako, uubo ako dito sa harapan nyo. Okay, back to work. 2, 2, 3. What do you call bars that are perpendicular to the main reinforcement of slabs or on field, where they prevent cracking due to contraction brought about by shrinkage and temperature changes? Temperature bar. Oh, temperature bars, yes. It is the height of the wall divided by its thickness. We call it B. Slenderness ratio of the wall. From the given plan, wala na naman tayong plan ha. Give the dimensions and spacing of the beams and columns. So, pwede kong i-adapt natin yung, nag-give an example. Yung bubuit natin dito kapag provide ng, ng plans, but basically you have to see an actual structural plan. Basta, sinabing nyo makapagbasa ng structural plan na bago nag-exam. Kailan nag-exam, Maylin? Pero January eh. Uy, ano na, what's na? Ilang pending na lang. Excited na sila, oh. Ay, mga bata nga eh. Oo. Thank you, ma'am. Tinidor. Tama ba nabasa ko? Incidentally, yes, I will. After this, yun ang ating. Gusto niyo unahin ko yun? Sige, unahin natin ha. Akala ko kapag ganitong live class, ituturo yung lumabas ng previous exam. Now na, I agree with you. So, tandaan niyo kung anong number tayo ha. So, let me just show you this plan. So, we will go back to 226 after mapuntahan ko yun. So, I would like to, I thank you for that reminder. Kasi ano eh, nakahiya naman sa inyo. Parang alam niyo na to. It seems that you know this very well. Okay? So, ito muna. Ganun pa karami kahaba yung i-discuss. And, ito naman yung additional info based on the latest exam. Tinanong, ano daw difference between Pratt and contrast? Ngayon, tinatawanan niyo ako mga bata kayo. Mr. Tinidor, sige, tumama ka pa dyan ng malakas. Thank you ha. Ito na nga oh. Ano daw difference? But there are two things that you have to remember. Mayroon tayong roof truss saka bridge. Look, ang Pratt truss mo, Pratt. At saka yung Pratt truss ng bridge, magkabaliktad. So, yung web members niya sa roof truss towards the, yung summit ng inyong, sa ridge roll ng inyong truss. Pero dito sa bridge truss, nakahiwalay. Tingnan mo naman ang contrast dito sa roof truss. Contrast is pa-V. Samantalang dito naman sa bridge truss, inverted V. Box na? Yan. Hindi na natin binura itong mga pansin ko ba? Okay, so, the design of contrast is the opposite to that of Pratt truss, in which the diagonal members are slanted in the direction opposite to that of Pratt. Ganun lang. Kaya lang, talagang nakakalito, confusing, kasi may roof ka, may bridge truss ka. So, since you are confined more of building, ito talagang pakatandaan nyo, yung roof truss. Dahil binibigyan na rin ng horizontal construction, hindi, ano masama kung alam mo yung bridge truss, di ba? So, dalawa lang naman pinag-compare. Next, identify connections. Hindi rin sinabi kung anong connection, but we have to try to identify the type of connection. Okay? Okay, so, ang steel beam connection, beam to beam, ayan. It seems that this connection is semi-rigid. Sapagkat, I cannot see any welded part. Kapag kasi, combination of bolted and welded connection, perfectly restrained yan, meaning rigid. So, ito rin semi-rigid, kadahilan ng this serves as, ito, tingnan mo yung beam dito, sa ilalim may nakaawang. So, this is bolted connection, which can be considered semi-rigid. Anong kaibahan ng rigid sa semi-rigid? Pag rigid kasi, it is good in resisting moment. Itong klase na to semi-rigid, ito yung kapag gumalaw ang building mo, makakarinig ka ng langit-ngit. Hindi naman, exercise lang yun, pero it can move a little, it can roll, it can move a little. But if it is perfectly restrained, talagang pag gumalaw isa, gagalaw isa, super rigid. I don't know if you understand what I'm saying. That types of connection kasi. This is another connection, wood tingnan mo yung number ninyo, with all this. Okay, so to make it fixed, kasi, can you imagine the column which is very thin, parang joke na ito, ayaw ko, makatingin ko lang yung column mo thin, tukod. So if it is just simple support, as in tukod lang, without the braces here, baka pumabuse yan kapag nag-move ang building mo due to earthquake. So this will convert the simple support to a semi-rigid support. Nagiging rigid support if itong mga braces mo dito, itong mga to, na naka-bolt siya, ay talagang sufficient para hindi nga mag-move. Okay, so malalaman mo naman. Another is on the right side, column to beam connection with the bearing plate. Another support, ito pa. So, can you see this mark? Okay, so ito yung, ibig sabihin, one piece ito, another piece on the left. Nagdugtong sila dito. So, how can you provide the supplies if we are talking about very big lumber? So, ang gagawin mo na lang, minsan ginagawa natin ng paraan, whether we provide a notch or ipapatong mo sa poste at we'll provide naman itong mga ito. Ang bakal nito yung nagsuserve as, to fix the upper part to the lower part. Okay? So please disregard this at least 1 inch because it is never equal to 1 inch. Ako nagkamali ang typist dito. Kasi considering a column, syempre, hindi po pwede. Kasi minimum yan, 6 by 6, 6 inches, 150 agad. So imposible 1 inch yan. So nagkamali. At least sa kalahati ilalagay para hindi siya ma-abuse. Splices in beams should be supported by a post or structural column of some sort. The post or column should rest on footing that meets local building code requirements. And the beam should be connected to the post with an approved metal connector. Beams should be supported by at least 1 inch of solid wood. Okay. Not yung fat over post. Plus, learn how to make structural repairs by sistering floors. Anyway, that is just okay, so may mga times na we do need to provide bolts o kaya tako. Hindi pa pwedeng basta ka na lang bubutas kasi this portion here will be weakened, no? So it might fail there, may break. Depende sa number of butas. Even the number of bolts here should be designed. Okay? Minimum of which is 4 times the depth. Yan ang distance, 4D. Sorry, 4 times the diameter of the bolt rather. Okay? Connecting beam. The standard way of connecting beams to columns is to provide moment transfer through full penetration butt welds. Kapag bakal, between the beam flanges and the column flanges, we call it strong axis connection. Or continuity plates, we also call this weak axis connection. And to provide shear transfer through the beam web connection. This illustrates that there could be, ito yung arrow na to, gives us what? Yung a force, which is compression force, na nakadirect toward the hole kung saan naroon yung bolt. Eh, sapagkat nagkaroon, alam mo yun, yung bolt at yung wood, magkaibang material. So as far as wood is analyzed, this will be considered hollow. Itong portion na to yung butas. Therefore, we will deduct from the strength of the entire structure yung butas na pagpapasukan ng bolt. But this just illustrates that if tension equals compression for to create a moment, di ba? So sabi natin, for stability, if there is a force going to the right, there is a resistance going to the left. So, couple sila. But illustrates only the distance. Yun bang mga minimum requirements as to the distance. So, kanina sabi natin 4 times the diameter of the bolt. Magkwenta ka ngayon, if the bolt is 3/4 of an inch, tapos ito 100 mm, so baka mamaya you're not consistent with unit, so you have to convert one in terms of the other first. Okay? Another connection with the metal and steel, concrete, with all this connector, steel connector. Kahit paano may connection ka dito sa pedestal na to, this is part of your footing and your rebars. So can you imagine, you can imagine what is inside it, that the column bars are bent, di ba? Doon sa to join the rebars on the footing. Another question was post found at the end of the stair. What do you call the post found at the end of the stair? This is an example. This is the lay, dual post. This one also is one example. Meron pa ba? Next, glass spigots. Maraming klaseng glass connector or support. Natuwa lang ako dito sa floor-mounted glass spigots, port drill spigots, deck-mount spigots. So, this will be considered structural because they support the glasses. Diba? So, anyway, this will be further discussed by your RT. Maybe all other types of glass supports. Source of sand used for plastering. Basically, river sand are used for any plastering work. River sand. So, dapat may river ka, gano'n? Hindi na ngayon. Kasi sa panahon nyo, ang daming bundok pinakuwari ngayon. Diba? With the aid of machine, paglabas niya sa machine, separated na yung sand from the gravel. Ang galing nga, graded pa siya. Kaya, yun ang ginagamit natin. Siguro nung sinauna panahon ko, talagang kukuha ka. River sand is actually, right? The basic, no? Generally, in any plastering work, plasterers use natural sand, crushed stones, and crushed stone sand or crushed gravel sand. Though there is a grading limit of sand which are used in plastering work, other types of sand will also work, but it could be more expensive to use. Oo naman. In mga provinces pa, uso pa rin itong river sand, especially if medyo malayo yung mga construction supplies ninyo. Okay, but make sure that the sand should be free from mud. Hindi po pwedeng may mga lumot doon, hindi pwede yun. So you wash it first. But anyway, you can imagine that the sand coming from the river is already a mixture. Hindi lang siya sand, may mga gravel din. Pero because we are using, the title is for plastering, para makasigurado ko that the sand is really good for plastering work, alam mo yung binibistay, parang may screen ka, parang kulang may metal, tapos sinasala ka ganyan. So yung lumabas doon, yun ang sand that are used in plastering. You do not use greater than that. Otherwise, magbubukol-bukol yung mga pader ninyo. Okay, next. ASTM standard for rebars. I got this from our ASTM, mga code. A955/A955M. Standard specs for deformed and plain stainless steel bars for concrete reinforcement. Is the main standard for stainless steel. Tandaan, this is stainless steel. Okay? Siyempre, USA, Canada, we are adapting naman America. Therefore, this is true to us. However, this is for stainless steel. Punta ka sa baba ngayon, ordinarily, yung ginagamit sa construction, ASTM 615. Covers deformed and plain carbon steel bars for concrete reinforcement. This specs covers bars and coils in grade 40, grade 60, grade 75, grade 80. The grade designates the yield strength of the material. So meaning, pag sinabi grade 60, ang minimum yield strength niya ay 60 KSI. 60 KSI or 60,000 pounds per square inch. Alright? So, grade 40, ang yield stress niya, 40 KSI. Ang grade 60, 60. So, kung ano yung number dyan sa grade, yun ang yield strength niya. Strength means lakas niya. So, kailangan, yung lakas niya, mas malaki kaysa dun sa actual. Okay? So, thank you for that. Next, another is ASTM 836, standard covers low carbon steels that are commonly used in construction and other heavy industries. So, di yata, may 8615, tapos meron pang 836. Alin ba talaga, kuya? This 836 kasi, ano to, yung mga pang-ordinary construction nga. Yung mga minimum, ito tingnan nyo, yung 36 yield stress yan. Okay, so yung 250 or 36,000 PSI range, ito. But anyway, the yield stress, let's read na. The American Society, the ASTM designate 836 by both its chemical composition and mechanical properties, especially yield strength, which must reach a minimum of 250 megapascal. Minimum yan for 36 PSI. So, minimum means, kung ang 36 na to, 36 or 36 KSI, wala, mababa ito kaysa dito sa grade 6, grade 40, grade 16. Nagkas yun? So, lumalabas na, grade 36 lang to. Kaya hindi naman, wala naman problema kung gumamit ka nito. For as long as the structural engineer designated this as acceptable. Okay, so kasi kailangan mag-compute para, malaman mo na this is capable of carrying the same load. Bar markings. Ayan. So, ano mga meaning niyan? Okay, kaya medyo tingnan na kasi lumabas recently. Ito, paalala lamang. Sapagkat, for what particular question, walang specific, but basta reinforcing steel bars. O hindi, itong mga available commercially, titingnan natin na, so for example, number 3, 4, 5, 6, 7, 8, etc. Ang number 3 bar, alam niyo naman that if you want to determine the diameter of this, you simply divide this by 8, tama? After dividing 3 by 8, that is the diameter in inch. Multiply mo ng 25, that gives you 9.375 millimeters, which is rounded to 10, because you cannot buy a 9.375 millimeter. The standard is 10. Bagets nyo? Ang number 4 bar, divide mo ng 8, gives you 0.5. 0.5 times 25, di ba? Nabibigay ng 12.5. But you cannot buy 12.5 in the market because the standard size is 12. Number 5, 5 over 8, 6 over 8, but no number 7. In the Philippines, there's no number 7 pa. Take note. So, kasi pag kung ang number 6 mo, alam ba, number 4, 12. Number 5, 16. 6, 20. Ang 8, 25. Wala kang 22. Wala tayong available yan sa Pinas. So, number 8, divide mo ng 8, 1. 1 times 25 is 25. That's why, all you need to do is, remember, if you are given the number of rebar, divide by 12, by 8. That gives you the actual diameter in inch or inches. Multiply mo ngayon ng 25 to convert to millimeters, then find the standard. Standard natin, 10, 12, 16, 20 na susunod, 25 na susunod, ano susunod pa? 28, o 32 na ba? Susunod, and then 36 and all. So, tingnan natin yung mga available in the market, ha? So, ano pa kaya ang dapat natin tandaan sa rebar? Maybe the weight that we discussed a while ago, maybe the total length, depende sa structure. So, the definitions here, the descriptions, saan to suitable? Yun lang. Saan to ginagamit? O, diba? So, kung number 5, 16, pwede na daw sa bridges and highways. Bakit? Pwede din naman po sa ano, sa building, sa mga building, etc. Alright, next. Ito yung weight ng steel. Just to recall, 750 kg per cubic meter. This is naman the converted in kilonewton per cubic meter, in grams per cubic centimeters, for 90 pounds per cubic foot, etc. Ito yung mga converted in addition to what I have presented a while ago. Ngayon, if you want unit weight of steel, ikaw, nabigay ko na kanina yung itong 6 na to kasi, wala to dun sa standard number 3. Number 3 is 10. So itong dalawa, 6 and 8, substandard yan pa ginamit mo. Ginagamit natin yan, siguro sa mga lateral ties na lang, sa stirrups. But in design, we strictly prescribe, and as minimum. Okay. So, kapag may 10 ka, for example, ito na yung kanyang weight, 0.67 kg per meter sa bawat metro, 0.6. Kung ang length mo ay say 10, multiply mo ng 10, 6.17 kg. Diba? Kapag in feet naman, hindi multiply ka lang length in feet. This is what if you want to memorize all the table, will give you easier kasi hindi ka na magko-convert pa. For stainless steel, aside from the one I presented a while ago, there's another ASTM designation for that. Ito, 304L ASTM 824D stainless steel plate ito is a standard blah 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 blah. So, kanina kasi for rebars and other sizes, but this is for stainless steel plate naman. PSI for class D, PSI for class D, PSI for class D concrete. Ano daw ang PSI na to? Ito yung stress niya. Ano yung strength daw ng class D concrete? 2,500. Therefore, baka tanungin mo yung class C, 2,000. Baka gusto mo tanungin yung class D, 350 to 3,500. Greater than this. Ito pala, for footing, 3,400, 3,500 hanggang 4,000 PSI. Okay, so may mga suggested structural elements where you can use. While for suspended slabs, beams, girders, ito naman ang kanyang requirement, 3,500 to 5,000, meaning class A or better. Next, PSI for non-load bearing CHP. Ayan. For non-load, minimum compressive strength is 4,000 PSI, 400 PSI or 2.76 megapascal. Non-load bearing. Therefore, yung kaya ko lang naman ito sinasagot kasi ito yung mga lumabas. Ha? Pero isinisingit ko na yung mga posibleng lumabas ulit. Kasi naitanong na to. Malay mo itanong na yun. Sa susunod, load bearing na. So load bearing lang na. Ito na yung kanyang strength. Ha? So may dalawa ka na ngayon. Ngayon kung, natanong pala dito, correct proportion ba daw ng class AA? Okay, pakititigan itong, ito. Kita naman ano? 1 is to 1.5 is to 3. 1, bagong sabihin, 1.5 cubic feet of sand, 3 cubic feet of gravel. Yan ang proportion. Yun ang mga tinatanong eh. Kaya lang, sa table na to, kakatuwa dahil binigay ng only class AA. Ang lahat nandito na para for easy reference ha. Pati yung kanyang kilogram, if there is a 50 kilogram here, ito na yung kailangan mo, bags. Alright, even the sand and graba. So, also, at the bottom part, meron ka na dito ano, yung class AA, minimum niya 4,000, class A 3,500, class B 2,500, class C 2,000. See? So, nandiyan na yung kanilang mga strength. That is strictly speaking, siyempre kapag umorder na concrete mix, naka-specify yung kung anong gagamiting strength. So, nagkukondak sila ng test, di ba? Yung supplier mismo nagkukondak ng test. Ikaw, pag nagbuhos ka, magkukondak ka naman initially slump test, di ba? And then you set aside samples, we call them cylinders, to be subjected to test. We call it compression test. Then, doon mo malalaman na, you got it better than what is required, any good. But if you get lower than what is required, patay ka dyan. So, you have to replace it or, you know, ipapaano yan. Ipapaalam sa designer kung ano yung kung pwede magawa dyan. Contractors know what to do, definitely yes. We have to be strict on the strength of concrete that we are specifying. It must be followed strictly. So, another, medyo mixture class proportion pa rin. In-enlarge lang pala for the whole. Yan. AA. Para lang malinaw. So, nilinawan lang. Okay? Additional info. Para ito sa class B, 1 to 2 to 4. Class A, mix na ngayon eh. Ayun. But anyway, if you are confused, this I took from this website. Kasi kung sa Amerika o sa amang bahagi ng mundo to, baka kasi minsan yung nakapost sa internet eh. Study lang pala ng isang doctorate student ay hindi pa yan upload. So, sometimes, kaya ko nilalagay yung source para makita nyo na, teka muna, hindi pang Pinas ito. So, it doesn't jive with the Philippines and ASTM. Okay, next. Class A mixture, 1 to 2 to 4. So, look here. If it is 1 to 2 to 4, dapat class A yan, dapat 3,500 yan. So, lumalabas na yun dito na meron siya in terms of the strength. Meron din. Pinapakita ko lang na you don't have to follow this. I want to put an X here because this doesn't jive with the ASTM standard. So, next. Class AA mixture is recommended for what? So, syempre, hindi ko nasinulat yung mga choices. Class AA, class AA, allows for new flats on detached buildings that are either commercial or mixed use with flats. 4,000 to 500, recommended for commercial. From the choices, ito na yung nilagay ko. Hindi ko na mamakita ko yung mga choices na yan. Basta para saan ito? Yun. Commercial, but definitely, we're talking about the major parts of the building. Yung can be in slab, beams, columns, and footings. Yun lang naman ang concern ko eh. Kasi yun ang mga pwedeng bumagsak. Pag yun ay nasira, affected lahat. Okay, so next. Find aggregate, sieve number. Ito yung sagot. Find aggregates pass-through and number 200 sieve. Okay, so ang size talaga niya, di ba yung, tama, number 200 sieve in our experiment way back college, di ba? So, siguro naman, natatanda niyo pa. For find aggregates, ito yung sand, around 8 inches or 200 mm. Yung, alam mo yun, saktuhan kasi ito eh. Yung rounding off, talaga yung saktuhan. But 8 inches is 200, 12 inches is 300 sieve are commonly used. Okay. Size of course aggregate used for slabs. Coarse aggregate, so graba. Ito na yung sagot niya. 9.5 and 37. So this is the range. However, gusto ko lang pakihinaw sa inyo na when we are talking of slabs for superstructures like skyways, kita niyo naman yung mga malalaking superstructures natin dito as in skyway, mga elevated. Ito mga bago ngayong mga bago natin expressways, mga elevated pa man din. So yung slabs niya, talagang maabot mo yung diameter ng graba na 37.5 mm. No problem about it. Pero sa building, just mayo, meron tayong code guided by NSCP Volume 1. Hanggang 25 ka lang. Kasi we're not talking about, siguro, why not, sa foundation. Pero yung bandang doon na sa ilalim, panambak ba? Kasi kapag may bakal ka, lalo na yung bakal mo, medyo closely spaced, kailangan makadaan yung aggregate mo doon. But if the bakal is malalayo naman, pwede okay, lalo na sa foundation. So makikita mo doon sa mga footing. Kasi malalayo yung kanilang mga bakal. No problem about it. Pero sa beam, masikip, di ba beam? So yung mga bakal mo doon, dapat hindi liliit sa 25 ang spacing. Kailangan makadaan si graba. So 25 lang. Okay, so I think yung mga sukat na to, more or less will remind nyo na ito yung coarse aggregate. So smaller than this will already be considered fine aggregates. So meron pa dito, 4 slabs between 9 and 25. O, ito pa lang, 9.5 and 25. Ito yung graba size niya, range. Pwede yan. 4 slabs, also for beams and columns. Pwede lang yung column mo ay napakalalaki like pier na. Kasi ang spacing niyan, medyo malalayo na. So you can. Nag-judge pa rin naman tayo based on actual condition. Ano daw size ng G4? What is the meaning of this? Mali ang ginugitan ng kung sinong naguhit yung matanda yun eh. So you consider this one, G34. This one. So mali ang naguhitan. Duling ba? Okay, next. Standard rebar for CHB, 10 and 12. 10 is the minimum, 12 is the maximum for CHB rebars. Sensya na, hindi ko nababasa lahat ng comments nyo ha. Pagka sabi nyo may replay, meron replay dito. Pati pala pag-ubuko may replay. Okay, so siguro nga, pakinggan nyo na lang ulit yung replay. Alright, so for standard nga, ng rebar for CHB, minimum of 10, maximum of 12. Ito, kitang-kita, 1 half is 12 mm. Okay, 3/8 is 10 mm. Vertical spacing of rebars. Okay, meron tayo dito mga sukat din, vertical reinforcement. But we're not talking about vertical reinforcement. We are talking about vertical spacing. Therefore, dito ka sa horizontal. Yung horizontal rebar ko, yun ang magbibigay sa iyo ng vertical spacing. So, ito yun. Okay? Load-bearing concrete. Load-bearing concrete. Parang tinanong dito yung pinakamagandang brand eh. Because jack built yung ating nata-specify. Ano yun? Para 7, I normally recommend when I prepare the technical specs, I put, to use Portland Cement or approved equal. Bakit? Para mapagbintangan tayo ng omisyon. Kasi ang Portland Cement is a brand. But because this is still the original, high early strength, madali siyang matuyok, hindi mo kailangan ng accelerator, kaya it's good. Therefore, para hindi ka mapahamak, maglalagay ka ng or approved equal. Paano kung yung kliyente mo may-ari pa rin ng semento? O bakit naman hindi po pwede? So kailangan lang i-approve yun. So kailangan natin malaman yung strength niya, is it as good as Portland? So ganun din sa Jack Built. This is CHB. Kaya, ano pa mga klase? Ano pa mga brand? Hindi ko alam kung ano pa mga brand. Please find for yourselves. So, load-bearing concrete. Ano nga ito? There is something wrong with the question. Load-bearing concrete, siguro wall. Kasi itong Jack Built is for the CHB yan. Pasensyahan na sa mga bubuetan, no? Yung mga nagbigay ng feedback na to. Now, dito sa baba, you don't have really to memorize all. These are specifications. Sa amin, big deal ito. Pero sa inyo, pakatingnan na lang ba? Yung halimbawa, load-bearing concrete masonry unit, CHB yan. C90, o yan ang designation. So, yan ang mga kanyang mga, pwede nyo makita. But, I don't know how the examiner interprets this, but as for me, ipinakita ko lang sa inyo na ito yung mga ASTM designation. This is more important. Pero, kung nakalagay, kasi ito kasama sa feedback kasama yan sa binigay sa info, Jack Built. Meaning, nag-specify siya ng brand. So, find out the other brands. Siguro not only for CHB, but other materials na po pwedeng gamitin ninyo. Siguro, all those that may come out. CHB ba? Ano bang pwede pang yung mga brand na gagamitin ninyo? Sa bakal ba meron ba kayong naiisip? So, medyo search na. Next, refined sand and white cement used for masonry works is called blank sand. Wala naman akong sa choices kasi, ito lang ang papasok. Ito lang ang papasok. Masonry sand because of this statement. So, next, size of gravel used for slab on fill. Slab on fill, size of graba. Pwede mo nang gamitin yung kanina from 9.5 up to 37.5. Kasi, for sure, the main bars here, including the temperature bar, are not so closely spaced. Nagets nyo? Doon lang tayo sa upper floor. Sa upper floor, saka sa beams and all. Pero dito sa ground slab, okay lang. But did you know that the drawing, this illustration here, gives us a pavement? Oo, pavement. So may concrete slab ka, pero bago mo yan lagyan ng concrete, meron ka muna mga base course, base, etc. So ito yung mga pinambak. So may graba, when we design airport, lalo international airport, may crush racks yun. Tapos yung crush racks na yun, cement treated pa yung ipinagay na graba. May crush racks ka, no? Eh di syempre, hiwalay. Paano mo yun, i racks na. So may mga awang, may mga spaces, fill up pa nito ng cement treated graba. Gravel and sand, no? So yun ang papasok dun sa ilalim, that will make the sa base course very strong. Pero kung building, well, magpag-take note lang sa kinaroroonan ng mga footing. So, yung mga footings mo dapat super hard ang iyong papatungan nito. Yung pinaka-soil mo is properly compacted. If the soil bearing capacity is not enough, you have to do something. The engineer normally recommends what foundation to use, what footing. If a single footing, but, spread footing yan, pero sometimes we provide tiles. Depende sa lambot o tigas ng lupa. Okay? Hindi niya pinto graba pa rin. Anyway, lang niya, naka-label pa. So, pavement pa rin ito, pavement. Pag sinabi natin flexible pavement, meron kang asphalt. Itong rigid, pinatang concrete. Weight of steel for 1 cubic meter. Again, I remark here, incomplete information. Kaya, parang kanina, di ba? Weight of 1 cubic meter of concrete. Weight of steel for 1 cubic meter of concrete. Ibig sabihin, kung may 1 cubic meter of concrete yan, what is the weight of the steel for that? O di ba? Itong source na, ito pwede nyo gamitin. Halimbawa, it's beam. Dito sa second tayo. Ito yung range ng kanyang weight ng reinforcement at kilogram per cubic meter. Per cubic meter, 1 cubic meter ibig sabihin. So this is the value. So there's no specific for that. There's no number. If I should put 150, I might be getting the maximum. If I use naman 100, I might be given the minimum. So basta within the range is acceptable. Basta, I don't know how you will remedy this problema, but I think, kasi sana naintindihan nyo, yung, kunyari may isang buong beam, syempre may bakal yun. So for this particular beam, computin mo yung volume ng concrete mo. Gaano daw kalaki yung weight naman ng bakal para doon. Pwede kasi gawin yun eh. But the question now is, per cubic meter of concrete, ano naman yung, yung bakal. A material that is 80% glass is fiberglass from the choices. Kung nga ngayon nabasa yun,
Pick na natin.
ito muna, dito. Ay, bakit natatakpan sorry naman. Joke si Lola. Correct yun January not matter. Ano yan? 780 kg per cubic meter. Ito, tinanong din, tools for wood cutting. Hindi ako sigurado kung di baka enumerate sa'yo kasi hindi naman din ng board. Diba? Meron kang pagpipilian. Kaya, dahil malabo naman yung tanong, hindi ibigay na natin lahat ng mga tools. Baka isa dyan lumabas. Basta isa dyan lumabas, I'm sure of that. So, for cutting wood, these are the names. Yan. Very common itong cross-cut. So, mano-mano. Pero meron naman tayong yung pinagtutulungan ng dalawang mama. Okay, meron namang power generated, etc. At lahat ito, pang-cut ng wood. Next, tools for wood cutting ay hardboard. There is something wrong with this na nakapit-paste ito ng natanda. Pasensya na, but the answer is hardboard. Find the question. It's like, napalitan tayo. Basta meron tanong dito na ang sagot hardboard. Pasensya na dito sa question number 29. Next, roofing materials that last for 100 years. Roofing materials that last for 100 years. Ito yung sagot. Bakit? May mga choices yan. I mean, yeah. A, B, C, D, ganun. But the answer is light shingle because of this. there are typically once in a lifetime replacement because hard slide last 100 to 200 years. So, pasok yan dito sa, ito naman pumasok dun sa criteria. So, I think you can search for the other roofing materials. Which one is the best? So, for me, this is the best. Okay? Number 21, steel roof suppliers. Sorry I have to beg off. I mean, your architecture professor will discuss this because I just had in my mind. So, okay ba? Supplier Pero, research na lang. Ano bang mga suppliers? Kasi, alam mo yun, kung ako yung magka-judge, talaga, pina-enumerate ba ng examiner? That is impossible. Kasi may pagpipilian ka. Maybe, in one choice, naka-enumerate na yung mga suppliers, tapos may isang mali. I mean, so kayo, mag-search kayo ng mga roof suppliers. Ang tanong, ano mga steel roof suppliers? What do you mean by steel roof suppliers? Are you speaking of metal sheets? Steel din yun? O galvanized iron? Is steel? So yun ang mga tanong doon Kaya be careful in looking for this. Next, steel roof suppliers pa rin. Sorry, suppliers of roof tiles naman. Hindi ko na sinagot yan kasi nga, you can search for that. This is more of architectural already. But you can search. Okay, so kinano supplier of roof tile, below. Parang hindi ko sinasabing mali yung bubuit natin nagbigay ng feedback. Pero there is a question regarding roof tile. And if it is a supplier then, from the enumerated, from the choices, meron doon lalabas na supplier na ng roof tile. So again, lumayo sa Metro Manila muna. So mga supplier. Tapos meron naman hindi nagsusupply. Next, supplier of bituminous, ganun din, supplier. Next, recommended side lap of what? Of roof. So, hindi sinasabing ito yung lahat ay mali tama. Pero pwede kang pumili, depende. Okay, so, this is possible. If it looks like a placa romana, di ba? O yun. Yung hindi ka papasukin ng ulan, ng tubig. Ito, okay. It looks like 1.5 or 2. Ito rin. Kung ako yung mag-judge from the choices, dito, I will not consider half lap lang. Kasi ang problema dito is, parang andali niyang pasukin ng ulan. Pero pwede naman What do you provide in order to avoid water to, to visit here? Siguro, may gagawin ka. Ito much better. Medyo, alam mo yung patong niya ay 1. Ito naman 1.5. Ito yung pinakagabi, masyado kang mapapamaan. So, what we normally recommend? For me, 1.5. Ito, kung nagtitipid ka, pwede naman, bakit hindi? Pero nilalagyan natin dyan na, ba't pinagtawag doon? Para hindi maganda yung tubig. Nag-i-scour yan So, ibig sabihin, pwedeng mabasa, especially if your purlins are made of. Kung still, di kailangan mo baka magbasa yan, mga galawang sagrad, what is the purpose of sagrad? Ito pang structure talaga. It prevents buckling. Okay, buckling laterally, yes. Kasi, can you imagine after or roof tass, yung tapboard, atas lang. So, yung mga purlins wala ka naman. Sagrad naman, nakatusok doon sa purlin. Alright, so you know what is a sagrad? And the purpose to provide, to strengthen ba? To strengthen. Or it prevents buckling. To make it short. Which material is used for top rails that's easy to maintain? Steel or mild steel. Dalawa lang naman ang pasok sa criteria from the choices. Ito lang. Next, what size of steel bars are used for column main bars? 16 minimum. 16 minimum. What size of steel bars are used for columns? Minimum lang to but we can use bigger. Bakit hindi? So, medyo may kulang. Ewan ko lang kung nakulangan dito ng minimum ba. What is the minimum size of steel bar? O yun. That is pasok na pasok ito. Okay, next. What do you call the process of adjusting the slope and elevation of the ground surface? Grading. Na cut and fill. So, pa-structural din yun. Cut and fill is called grading. Next. What do you do to adjust and fill soil on an area without introducing foreign soil? You don't put any foreign soil. Wala kang embankment, wala. Pero what do you do daw to adjust and fill soil on an area without introducing foreign soil? Hindi ko masyadong nag-gets yung nagkukontrakan kasi without introducing pero nag-fill ka. Ano yun? When you fill, nananamba ka, nagtatamba. So it is impossible na you don't introduce foreign soil. Foreign means it is not the soil there. It can be coming from somewhere else. Not necessarily from abroad. Nagets naman So if you do that, you are embank, or you are filling. Pero if you do not introduce without introducing foreign, but you are filling it up, siguro, naisip ko lang, loose soil yan. Yan, fill ka, so nag-fill ka coming from the neighboring lot, o yun, hindi ka nanguha ng pag-imbang material. Hindi ka walang polling, walang overall, something like that. Hindi ka na mismo, o yun. Magkukumpa ka pa rin. Kasi nag-fill ka That's the idea. Anyway, please judge, Ang sagot ko, base sa naintindihan ko rin dun sa tanong. Yung tanong kasi medyo kulang, malabo. So medyo, kakapain natin yung pinakamalapit. Ganun naman yun. What surveying work is done when determining the property line of a site? Property line boundary something. That is the nearest from the choices. So when we talk about surveying, we can be talking about what? Topographic surveying, Topographic survey is just to determine whether it is flat or, alam mo yun, meandering or something like that. Bundok ba yan or plain? So you will see all the elevations there, bundok or not. Yun ang surveying na topo. Pero another surveying is, yung bang geodetic surveying, what we call that? What is that? Lot subdivision na yun. So geodetic, di ba? Malalaman kung ano yung mga property. I mean yung boundaries. So pag naglagay ka ng buhon, for example, that means that your lot is only within the boundary of that buhon. Di ba? Paano na yan? Naka-indicate sa land title. But what if, yung muna wala? For whatever reason, paano na yan? Hindi magpaparesurvey ka para ma-locate yun. Kasi may description na yun sa title. That's why when you buy a property, make sure that you check kung ano yung property lines niyan. Yung mga katabi dito, sino katabi sa south, sa west, naka-describe yan. Pati yung mga bearing. Therefore, kahit mawala ang buhon na yan, Mare survey yan. Maipoprovide mo kung saan yung pag-aari mo. Pero this is very specific eh. Determining the property line of a site. Gusto ko nga gusto ko yung sagot sana dyan, idiotic eh. Kaya lang, masyadong malayo, malawak yun. Kaysa dito sa boundary determination. Kasi ito lang ang pumasok sa pinakamalapit doon naman sa tanong. Okay. Next. So, the rest of the questions were more abstract. Ito lang yung latest. So, balik na tayo ha. Kasi, naku, medyo nakapos tayo. Talagang anong nanggan na ba tayo nga? Alam ko, tapos na tayo dito. Tapos na tayo dito. Tapos na tayo dyan. 200 na yata tayo, no? Meron wall system. 226, thank you. Ayun na. Yun. Which among the list is the preferred location for a shear wall or utility core considering seismic condition in a 15-story building with a width of 15 meters and length of 25? Siyempre sa sentro. Kasi isa lang ang kanyang shear wall, utility core. It is the general term for forces that act on a building. Load. General term for force. Load. What force does a curtain wall resist? B. Its own weight and the wind. So kahit na inaakala mong manipis yan, it has its own weight also. If a glass can withstand high compression on its outer fiber, tension on the center, how do you describe it? A. Bilisan na natin kasi hanggang 372, oh my gosh. What do you call two or more materials that are combined together? Composite. From the given figure, which one is the most structured and sound? C. Bakit? Ito, ang bigat-bigat niyan. Ito naman, walang tibay maasahan sa B. Kasi ano ba ito? Little beam ba yan? Yes, it is. Ito naman may additional load. As far as structural soundness is concerned, C. A web found in a structural member? Button. Another button. It is the middle part of the wide flange? Siguro, kanina pa yan, web. The architect asks you to order from the supplier 8x35 wide flange steel. What do the numbers designate? 8 inch, ang 8 mo, yung depth. Yung 35 mo, pounds per linear foot. So weight, depth, and weight. Difference between wide flange and I-beam? Ay, kanina pa. Basta, ang I-beam, the flanges are narrower. Mas maliit. Okay, yun lang. So kung titingnan natin yung ganda, which is advantageous, syempre ang wide flange, may advantage kasi mas malaki yung load na makakarry niya. Pero mas mabigat siya. Yun din eh. So ito na nagaan, pero yung contact dito, yung bearing area niya, mas manipis kaysa dito. So pareho lang yung property. What is produced in continuous process of cold roll and hot roll? Various varieties of steel. Kasama din ang deformed bars. What is the use of purlin? Parang kanina pa ito. Support the roofing materials, the wind load, and distribute the load to the rafter or truss topcourt. What is the use of cleat? Prevent the purlin from moving. So make it fixed there by putting cleats. A brick wall is weak in tension like concrete. What is the resultant uniform load? What is the resultant uniformly distributed load? Get the area of that rectangular load. Get the area. For example, ito yung rectangular load mo. The length is in meter. The height is the intensity of load. If you multiply L by W, ito yun, WL, makakancel yung meter mo. Ang remaining unit is in kilonewton, which is the unit of a load. Kaya kung mayroon kang tatsulo, triangular load, get the area of triangle. 1/2 times base times height. Convert. Next. Muna. Ang ganda pala sa pinakatanggal na ano. It is also known as elastic limit deformation. When a beam is in its elastic limit, which among the situation below would most likely happen, beam will come back to original state or original shape and size. Kasi nasa within ka ng elastic limit. Okay, may rephrase lang ako dito. May binalita na. The section of a beam at which the bending, at which the elastic curve changes from positive to negative, and at this point, the bending moment is 0 is inflection point or point of inflection. Ayan, na-discuss na siguro natin kanina pa yan. Points of inflection, pinaghiwala yung concave up to concave down. Inflection. Ayan, na-discuss na siguro natin kanina pa yan. Points of inflection, pinaghiwala yung concave up to concave down. A property of material that enables it to undergo plastic deformation after being stressed beyond the elastic limit and before rupturing, ductility. Kapal pa ng brittleness. Okay, definition pa more, but no need. A property of material that causes it to suddenly rupture under stress with little or no deformation, yan, brittleness. What component of steel dictates its ductility? Carbon. What is ultimate stress? That's the maximum stress a material can withstand. Material can withstand, but I want to emphasize that the code does not allow us to reach ultimate strength. That's why we are required to provide reduction factor. Kapag ang material mo bend, 0.9. Safe and economical. Kapag shearing, ang mangyari sa kanya, 0.75. Torsion, 0.75. And on, kanina napakita na natin yan. A slide curve built intentionally into a beam, slab, girder, or truss to compensate for the anticipated deflection. Tama yan, camber. Idea for camber? Ito yung kaliwa, normal condition. Ito naman yung providing camber. Pag hindi ka naglagay ng camber, pag nag-load ka, ito mangyari. Pero kapag naglagay ng camber, pag nag-load ka, kakantay na siya. Kung mag-deflect na super higit. So that's good because it will not exceed the minimum allowed by the code. Good if you provide camber, but kapag building yan, paano kung yan boom? Mag-straighten, paano na yung beam mo? So we do not do that for building. Sa mga tulay o bridges. Sa beams, kung ayaw mong magkaroon ng deflection, mag-pre-stress ka, pwede naman. How is camber treated in steel truss 25 and longer? Okay, ganito. Just try na lang natin. Parang, just me. Copy pa more. Ay, ano naman tanong mo? 243? Balikan natin. Ayan, inflection point. How is camber treated? Ito. it's not a truss, if it is just a beam, what I do, kung quick case analysis, kung ako yung magte-take ng board, itong gagawin ko. Yung beam mo na to, I compute for the minimum, yung allowable. Dalawang naman pagpilian mo dyan eh. Either L over 240 or L over 360. Kung alin ang pinaka maliit doon, pinaka malaki pala, yun ang aking gagawing camber. Kasi ang idea, pag babalot siya ng ganun, ay di camber mo ng ganun para pag dito din ng ganun, mag-flat lang. Yung idea ha. For a beam, what is the camber direction? Upward. For a 3 meter concrete beam, which amount of camber can be allowed? 12. Bakit? Sabi ko nga mag-compute ka na allowable. So ito yung mga actual. Ito yung mga actual reflection. Pero ikukumpara mo to dun sa minimum. So mahabang kwentuhan ito. Okay? The reason why I am introducing that, it's because it is difficult really to compute for reflection due to camber because mayroon ka ito yung mga formula mo. Pero nevertheless, you can use the deflection limits na. Deflection limits ito. So syempre, the bigger the denominator, diba, the smaller the value. L over 240 for the dead. Ano gagawin mo dyan kung combination ng live with dead? O diba, di ko computin mo pareho. Tapos, i-add mo ba? Yes. Because you are combining the live loads. We mean gravity loads. But if it is just dead load, ito lang gagamitin mo. So magko-compute ka talaga and then that will be the camber deflection that you will employ. Para lang sa quick determination. Ngayon, gusto ko lang sa inyo ipakita yung camber deflection. Ito yung deflection due to the dead load plus 1/2 of the deflection of the live load. Mahabang kwentuhan ito, mahaba. So I use na lang the limits. To zero the deflection na. So I'm not saying this is the only way to do it. Kaya nga may discussion tayo dito. If this particular solution is seen by some structural engineer, they will always, no, that's not right. Of course, this is not the formula in getting the camber deflection. I am just using this for the sake of quick determination so that there will be no problem when it comes to deflection. Parang, ito yung magiging deflection niya, ilagay mo doon, para pag dinagano mo, hindi din siya bababa. Yun lang yung idea doon ha. For a 4 meter concrete beam, which amount of camber? Ang ganda naman. Pwede mag-compute ka na ulit. So if I were to consider, I cannot add, I have to choose only the biggest. So I will make a camber of 16.67 mm kasi magiging, masyado na siyang mataas, kung kurba na siya. So makikita niyo sa mga tulad intention talaga na kurba. Lalo sa mga sa mga 5 or something. Okay, yung mga halimbawa, interchange, makikita niyo. It is a structural system without a complete vertical. Naulit yan. Okay, kung naulit man sa isa, hindi good. The maximum action load that can be theoretically applied to a column without causing it to buckle, critical buckling load. A thick column subject to failure by crashing rather than buckling, short column. What makes a long column buckle? It's not correct. It's not axial compression. Kaya ako naglagay ng question mark. It is due to the slenderness. Or maybe you can think of the length, but it is more of slenderness. That is why there is such thing as slenderness ratio. We most likely fail due to buckling long. Usually fails by both crossing and buckling intermediate. Pedestal piers and compression blocks are considered short column. What is the minimum allowed dimension of the reinforced concrete column? Ito na sasabi ko kanina sa inyo. The minimum allowed is, alam mo yun yung ground. Yan. Kung isang floor lang yan, ito na, 225. Plus 1, ayan na siya, kalaki na ano, ayan. Nasaan ang 200 dyan? Walay. Kaya lang naman ito nagaganap. Kapag kayo, nakiusap, engineer, gusto ko parang wala, kahit meron. Alam mo yun, parang gusto niya last para service. Ang linis tingnan. O hindi ikaw na mag-design. Joke lang. So, ang ibig ko sabihin is, if these are the minimums for this particular number of stories, hindi, ano to? Para bang hindi mo na kailangan structural? Ikaw, take the risk. Okay, kasi may bakal pa yan, wala kang bakal nakikita dyan. So, paano naman bigyan nyo rin kami ng trabaho, ha? Ba't yung tinatabahan? Okay, next. Malapit lang, kayo malapit naman, 11:30. L over R is known as slenderness ratio without K. That means, kapag L over R lang, yung K mo equals 1. Bagets naman ano? Ayan pa yung K L over R. Pag walang K, it means 1. Ito yung sinasabi ko, yung kanina pa. What does slenderness ratio determine? Effective length. Or slenderness. Ay, length na rin. Hindi porket long column basta it is measured, kasi tinatawag siyang long column, kahit hindi mo talaga long, kasi nga, slender siya. Yun ang pinaka-idea doon. So if you are to be strict in the definition, slenderness ratio is the geometrical property of compression member, which is related to the ratio of its effective length to its least lateral dimension. Okay. It is the extent of space between two supports of a structural member, effective length. It is the distance between two supports measured from the inner faces of the hollow. Clear span? Yes, clear span. Clear span. It is the center to center distance, effective span din yan. Effective or design span. From the center to center is design span. But please don't be confused kasi sometimes itong effective span is also the same as clear span, effective yun. But in effective length. Kasi paano yung span or length? Kasi yung span mo, distance between supports. Kapag set ko, tama naman. Because the definition of span is distance between supports. So tama naman, sorry. I will not react myself. Plan reading. Ito na. Papasok yung structural design nyo, drawings, na kung saan there were questions before given. The footing table, reinforcing bars, reason for by layout, number of bottom bars, top bars. Direct count ito beam slabs, schedule, etc. So, sana, maging malinaw yan sa pagbigay. Kasi gusto ko lang ipaalala sa inyo na ang plan reading, ang bawal lang ay doodling. Promise. Yun ang feedback. Kahit hindi ka na mag-site, basta nakikita ka na daw na nakahawa ka na ng plano. Kaya tapos ka na. Kahit na yan, bungalow house. So, I will not touch much on this, except if you want to, after 11:30. Sensya na kulang tayo sa oras. So, footing schedule is given. This is a schedule, but this is only part. Just to show you that there is something as tabulated data. Nakasummarize pa. Okay, nakasummarize ang column mo, mga dimensions, footing na rin din. So, makita mo yung width, length, etc. pati bakal. So, pag wala dun sa plano, punta ka sa schedule. Kung wala sa schedule, wala sa plano, magsukat ka. May scale yan, I'm sure. Pag wala pa rin, nagreklamo ka na sa proctor. Baka reasonable yung complaint mo, magiging bonus siya. Okay, so much about the plans. Actually, I have already shown this to you. Ito yung number of bars. Anyway, this is just how you will compute it. 250 divided by 62.5 equals 4. Kung ito ay tama. Pero, magdadagdag ka ng isa kasi may dulo ka. Anyway, kung ang distance mo dito, ang spacing mo 62. Kasi itong 62.5 na yan, based doon sa sukat. Kaya ang explaining dito was, what if you are using 75? 75 is the maximum spacing of yung pitch ba? Yung pitch mo dito, maximum 75. Ang minimum 25. Eh, ang 62, pasok sa range. So, malalaman mo ito doon. Kung gusto mong malaman kung ilan talaga yung bakal. Anyway, simple computation, di ba? Foundation, footing, spread footing, bakal, yung mga, ito kulang ang data kasi, yung vertical bar mo yung binabaluktot yan, pag ganun, ito pala. So yan, naka-protrude siya dyan, tapos hindi pa dyan binabaluktot. Okay, so, just to show you the structural plans that you may be interested looking at. Soil testing is done where? During site investigation part, wala kasing pwedeng pagpilian na tama. I mean, considering a designer, no, and a consulting company, we do the geotechnical engineering. This is considered pre-engineering, pre-design works, pre-design phase. So, during that pre-design phase, what we do, syempre yung site investigation, tapos yung topographic survey, hydrology survey, tapos ito yung technical investigation, yun ang ginagawa bago ka maka-design. Siguro sa preliminary design, you already used to build in other information, pero preliminary design lang yun. So, however, in our report, especially in the geotechnical engineering report, geotechnical investigation, we normally say that, mag-comment kami doon na, the contractor shall, yung take, halimbawa, take siya ng boring, pag soil test siya, for update of the geotechnical investigation done before. Kasi, normally, pagka nasa design phase ka, bago matapos yan, isang taon, 2 taon, di ba? Malaking project. Ay, depende yan sa project. Kung yung ginagamitan ng geotechnical investigation, malaki na yan. 2-story minimum dyan, pag-building. Pero yung mga bridges and all, roads, automatic yan. Wala namang floor yan, pero we are required to conduct geotechnical investigation. Meaning, ginawa pa lang yung design ngayon, mga 5 years from now, bisa pa lang ma-implement, gobyerno pa. Joke. Yun. So, if without budget, matatagalan. Kaya binabanggit namin sa report na, the contractor should conduct soil investigation, maski at random na lang. Okay? Kahit na at bawat year na lang, kasi yun ang critical. Baka nagkaroon ng change doon sa actual site condition. Kaya kung ako, mag-judge on the viewpoint of contractor, pwede ko piliin B. So, paki-judge ito based on the question. Kasi baka itong soil testing is done, baka putol ito, baka may kulang information. Ganito yan, geotechnical investigation is done prior to design. Okay, we cannot design without the CBR and all. Okay? However, before actual building na, so nasa contractor side na, nasa contractor na, ikaw contractor, you are required pa rin na magtunda. So, before excavation na. Debate mo so, ayun ang malalaki na kayo, Okay, konti na lang, promise. For the geotechnical investigation, soil boring, and jump site, ISTM requires standard penetration test, 1.5 depth interval. Okay? Up to what depth should the soil boring test be done? Up to bedrock. If the bedrock is so shallow, may bedrock na, kami nire-require namin up to 35 meters down below. 25 up to, 35. Lalim, no? Huwag kayo magkala yung boring naman yan Wala pa lang yan Parang tutusok lang yan. Walang malaking excavation dyan, wala. Which of the following do not determine the number of boreholes? Height of building. Kasi nasa size yan. The minimum number of stories for buildings with occupancy more than 100 before the technical reports to recommended in order to evaluate in situ soil properties for foundation design analysis, 2 stories. What is the minimum number of boreholes for a structure whose footprint is less than 600? That's kasi kapag 500, 2 na agad dyan, 500 square meters. Pagka lumabis, may plus 1 ka. So magiging 3 ngayon to. Plus 1 ito ka. What is the minimum number of borehole for structure whose footprint is less than? Kung less than, nga? Kasi kung less than, ito yan. 500 na, 82. Kapag lumabis, plus 1 agad. Yun ang tandaan nyo. What is the minimum diameter? Number of borehole? Ulit. Is 600. So, 3, sorry, pali ito. It must be 3 na. 600. Which of the following has the least soil bearing capacity? Silt. It is the moving or materials in depositing, grading. It is the main structural member of a wooden floor, floor joist. Also consider the beam from the list, joists. Most likely failure of a retaining wall, punch a hole on the wall, not included in design. To avoid hydrostatic pressure to force forward a retaining wall, what must be the best thing to do? Maglagay ng drainage. When a weak soil layer is located at a shallow depth within the depth of 1.5 times the width of the base slab of retaining wall, what should be placed behind? Maglagay ka ng backfill. What type of failure are this? Una, ito yung A, overturning. Yung B, sliding. Yung C, bearing capacity failure. Tapos yung D, deep-seated. Pero ang deep-seated mo, pwede rin ito, yung talagang naiba yung kanyang yung lupa mo talaga yung na-move, kagaya nito. Alright? 286, from the given figure, what kind of retaining wall is C? Undermining. C, undermine. Ito pa yung different types. Ito naman, undermining pa rin. O, underpinning naman. Para lang ma-differentiate natin yung undermining tsaka underpinning. Ito, mga iba-ibang klaseng retaining wall. Ano yung figure A? Which one is gravity wall? A. Next, anchored. D, anchored. May anchor. Piling. B, pile. Mukhang patusok, nakatanim. Anchored wall na naman. Ulit. So, ito lang ang sikreto, ha? So, have a copy of this because this is given in the board. Baka maulit. Ito yung kapiliban natin, makita mo na meron ditong to be, mag-backfill ka dito. Alright. Siguro, additional retaining wall, ang tawag dito is counterfort or buttress. When a building or part of it rises to the upward heave in a clay subsoil or chemical expansion regardless of the building's weight, Ano tawag dyan? Meron ng bearing failure. Example, you've got bearing failure. You were assigned to supervise the excavation for foundation. However, when work reaches the depth indicated on the plans, you discover that the soil is loose or soft. Ano gagawin mo? Siyempre, kailangan mo mag-decide kasi exam to eh. But, gusto ko mag-comment muna ha. You are the supervisor. You cannot decide to alter activities and schedule without prior approval of the client through the design consultant, the engineer of record. He must report his findings to the PM as it will incur cost unless he will shoulder the cost, which is impossible. But if I should select, wala akong choice dito kundi itong less evil ba? Less least evil. Meaning, itong lahat ng itong problema ito, malaking gastos ito. Will delay the construction cost, the construction schedule will also increase the cost. So, pati yung labor mo, lahat-lahat. Ito yung lesser evil nga, ika nga. So, but, kung talagang kailangan mong mag-report mo ganito, should you not alter the schedule, magdidesisyon ka, pero if I were you, all away, para sa solution na kagad. Okay? Backfill should be placed in layers 200 minimum. 200 mm, and then compact, take FDT. Pag na-satisfy na yung desired strength, fill again, 200 mm lagi. No fill should be placed adjacent to the building unless such building or structure is capable of understanding the additional vertical horizontal blah, blah, blah. That's 95, meaning 95 is already acceptable by ASTM. Ano yung 95? 95% of what? Of the strength that is desired. Kung maka 100 na perfect yan. But 95 is already acceptable. Back wall is transfers lateral forces, shear wall. Tangential stress, shear stress is also sometimes considered tangential. Effect of torsion twist. Combination of intermediate moment resisting, dual system. Okay, hanggang dito na muna tayo mga anak ha. Na-discuss natin itong mga bar marking. Why is the truss designed to have bottom part? Subukan mo wala. And joke lang. Okay? Kaya kung pipili ako, kung yung pipili ko, wala akong choice eh. Pero tandaan mo na ang bottom cord serves as yung connector between all the parts, then transmit all those loads to the supporting beam or polo. Sample pa more. And remember the different trusses. Next, given an isometric view of truss and roof framing, what is the tributary load of the middle truss? What is the span? So hindi ito choices kundi ano daw ito. Okay, so what is the tributary load of the middle truss? Ito yung middle truss, binigay ang tributary na yan. So it is 12, kalahati nito, kalahati din yan. So this is also 12. Multiply by, kalahati din yan, ito 10. So bali total is 20 kasi ito yung magiging, kasama yung kabilang. Okay na, from the answer here, it explains very well. You don't have to get the upper, slant. It is the horizontal projected area. So the span between trusses is 20. Kasi ito yung truss, ano? 20 feet? What is the span between trusses? 20 feet? Baka 12. Truss 1, truss 2. Sorry, it must be 12. Wala namang 20 dyan. Correction ha. Okay, letter B, 302, 12. Kasi na, super time na tayo. 303, napagay po. Furniture is considered live load. 304, testing of concrete when using transit mix is done in laboratory no matter what. Testing lang. What do you call a foundation not larger than the perimeter of the building? Floating foundation. Okay? Big. So floating foundation. Floating foundation. Floating foundation. Next, this type of foundation is frequently utilized as method to reduce or distribute building loads in order to reduce differential settlement between adjacent areas. It is typically used when there are poor and weak soil. Ano? Not footing, distribute, avoid settlement. Yan. It is formed solid or tool group in a concrete structure to create a weakened plane and regulate the location of crack. Is contraction joint. Contraction joint. Next, this is an example of contraction joint. Next, showing also expansion para makita yung kaibahan. Okay? So, this is contraction joint. But this one is construction joint, the one I was saying. Yung hindi siya ihinto ng diretso. So, nilalagyan natin ng ganito. Okay, so much for that. These are cracks. Ang tawag dito ay unwanted. This is unwanted crack. Kaya dapat mayroong kang contraction joint. Kasi kung hindi, magkakaroon ka ng fold joint. Okay. So, next, when laying concrete, it is sometimes not possible to pour one in one setting. It can be due to whatever reason. Hence, there will now be separation between old and new. And what do you call that? Construction joint. So, pinakita natin yung construction joint kanina. Dowels are provided sometimes. Sometimes, you just make it corrugated or rough. It allows the independent movement between adjoining structure member in order to prevent cracks. It allows the thermal expansion and contraction. We call it expansion joint. It has something to do with thermal. Yan. Expansion joint. An undesirable discontinuity in concrete occurs when a layer of concrete hardened before the rest of the concrete is poured. And what is meant to be a single solid mass? Ito yung kasasabi ko kanina. Cold joint. We don't like this. These are cracks. Alam mo yun, kalat-kalat yan. Kaya, unahan muna mag-contraction joint ka. So, unwanted joint. Yan na lang muna. Unwanted joint. Cold joint. Construction joints in floors shall be located within block of spans of slabs, beams, girders, middle third. Okay? Ito yung sinasabi natin kanina na kahit sa beam, pwede, naglalagay tayo ng dowel, tapos ito tayo yung in-stop, or again next time. So, with this, this is from ACI. Joints in girders shall be offset a minimum distance of how much? The width of intersecting beam, 2 times B. Ito, pinakita sa atin dito. So, at least 2 beam widths. 2 times of the beam widths. So, 2 times the width. Okay, so next, what is curing? Retaining of water through hydration, wrong. Retaining of water to complete, ano bang complete? Complete the hydration process. So, it may be addition or retaining of water to complete the hydration process. Curing is the maintaining of an adequate moisture content and temperature in concrete at early ages so that it can develop blah blah blah. So, curing, sprinkling, burlapping, post-tension, na-discuss na kanina. I-concrete member, tensioning and reinforcement after the concrete has hardened. Tensioning. Pre-stressing, pre-stress. Concrete reinforced pre-tensioning or post-tensioning or pre-tensioning. High strength steel. So, ang pre-stress refers to both pre-stressing or post-tensioning. What do you call the wires, cables,
where jacking force is applied, tendons, tendons. How do you connect the pre-stressed concrete to reinforced concrete? Use dowels. Advantage of steel over concrete, its elasticity, na ulit. Which is better design? The best is balanced design. But if you cannot attain this because that is difficult to attain, better use the lesser evil. Under reinforced. From a given plan, the foundation resting on we have no sectional view. You judge it from the plan. From the given plan again, so judge from the plan. Sorry, my dearest. So plans are really needed. Okay, ito ang napaka-cute na binigay sa exam na matagal ng panahon. Mga ilan na rin taon nakaraan, 5, 4. From the given figure, identify the structural part. Ang cute, no? Tagal pa yung pag-drawing kaysa dun sa pag-identify mo. What's that? A, Berlin, B, etc. So from the given plan, in schedule. So ito yung mga possible questions. Kaya lang, tingnan mo naman below, how can we answer? Never mind, it doesn't matter anymore for now, but we have already presented one clearer floor system in which we were able to get the clear distance. So just do that. Tapos, paano mo naman, alam mo yun, yung how will you not compute for L over 2 because divide by 2 or divide by 3? Yeah. Actual count. From the given figure, what is the distance between A, B, 3A and 3B? 3A, 3B. Ay, di 6 kasi nagkataon nakitang-kita mo 6. From the given plan again, identify cantilever footing. Wala kasing plan kaya I don't know. Ito gawa-gawa ko lang ha. So this is cantilever footing or strut footing. So types of footing, never mind. From the given plan again, determine the reinforcement of footing 1. Wala na ulit tayong pinagay na plano kaya tingnan nyo na lang kung it is possible to count from the given figures. Direct out from the plan please. Refer also the schedule. Konti na lang mga iha, mga anak, konti na lang. Okay, so from the given plan, what type of footing is F5? Sorry, pinapakita ko lang sa inyo na talagang madugo itong mga tanong because I cannot see the plans that they were thinking. So we have pasted here some figures where you can see. From another given plan, determine the footing of column P3. Judge from the plan. It can be isolated footing, combined footing. In swampy area, what type of 10 na lang, 10, ano na lang, number. What type of soil should foundation rest? Below. Very hard. Naglayan, erects, commercial building, dating rice field. Saan dapat erect? Kaya pinaka-mga siyempre pipilit nyo. Residential condominium built, former rice field. What type of foundation? C. For 332, assuming site will be on floodplain. Alam mo yung floodplain, mga putikan na yan. What foundation should it rest? D. And then, depth of footing converted rice field. Ganun din. So, ito, away muna tayo. I want to tell you that it is not fair to ask this question for structural engineer because we need to compute. We need design. So, depends on the complexity of structure. Ano ba yung building mo? Ano ba yung project mo? Is it a residential house, a shanty, or mall? Huwag kayong mangkula dyan. I refuse to answer, sorry. 334. The minimum depth of foundation supporting 3 floor slab. Ayan na naman. So 3 floor, kahit 3 floor pa yan. We have to design because it depends upon the occupancy. Residential ba yan? Condo lang ba yan? Baka mall. So, depends on the soil bearing capacity and all information coming from the pre-engineering works. Assuming that the site will be in adobe. Well, assuming all adobe, syempre okay na dyan yung isolated. What we have to design pa rin. What foundation presents the least disturbance? Pinaka-counting disturbance? Isolated from among the choices. Isolated. And then, board file naman para dito sa most disturbance board. What are piles placed at an inclination? Matter piles. Driven piles of uniform section shall have a nominal outside diameter of 250 NSCP 2015-200. So meron tayong reference, 200. Yeah. A concrete beam placed direct on the ground provided is grade beam. A concrete beam on the ground, grade beam. A method using in driving pile sand, blah, 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 is jetting. A form of driven piling using thin interlocking sheets of steel. Sheet piles. Sample. Discuss difference between grade beam, tie beam. Illustration na lang ha. Ang grade beam, tsura. Nasa baba, nasa lupa. Ang tie beam, kita mo naman, connecting bedvis. Tie beam. Ayan ang grade beam. Plate beam. Okay, isolated, strap beam, strap, puti, pala. Inverted beams, upstand, blah, blah, blah. Ito, may mga talagang ganito. What figure will discuss with you will tell you, bakit may ganun? Sometimes, wala, trip lang din. Kasi pwede namang inverted, pwede namang nakataob. It's just that, yung kanyang lakas, pinakamahalaga pa rin yung kanyang strength. Okay? Sometimes it depends on anong use kasi baka kailangan balik pa rin. Kasi kailangan malaking malapad na area at the bottom. So go ahead, pwede yun. So sample. Sample also. Ito yung upstand beam. Naka-usli, pataas. T-beam. Marami kasi kaya. Discuss, show how to use illustrate the following. Strip, isolated. Napakita na natin yan. Ito, continuous or straight. Yeah, spread. Combine. Step. Sloped. Cantilevered or show. Eccentric. Raft. Mat. Isolated or spread again. Next, in an ordinary site, where should the foundation rest? Very hard foundation. On a site located in Pasig and Marikina, fault line, where should the foundation rest? Where? Hard pa rin. Iwasan mo yung fault line kung ma-determine mo. What should be used so that the construction would not affect the adjacent structure? Sheet piles. Which should you use to minimize disturbance to adjoining properties, strip footing? But you have to design, you have to know, based on the need. The soil or rock directly beneath the footing is foundation bed. When a perfectly restrained member under compression assumes deflected position, buckling. Pala, gutom na tayo. What is the property of steel which is strength? Which happens to be the weakness of concrete? Elasticity. In part CPM, the difference between the schedule and actual accomplishment is slippage. 354, while traversing EDSA, ito yung sinabi ko sa inyo, MRT issue. Elevated. What do you call the concrete portion of the MRT running parallel to the road? It's ray beam. Ray beam. Study different kinds of trusses. Magmemorya na rin, ha? Yan. So, the distance between trusses, bay length. This truss was patented in 1840, Nino. Yan. How truss? Yan ba? How truss? How pa rin? Ito naman Fink Truss, ni Albert Fink, 1854. Ito naman Gambrel, walang pangalan pero kailan in North America. Gambrel is a Norman English word. So it's just English, Norman English word. Well, anyway, kung sino man ang contributor niyan from Harvard University. Trusses are formed using triangles. What happens when a column rests on a footing not reinforced with rebar? Siyempre, column will punch a hole. Magkaroon ng punching failure. From the figure, what is the volume? Last na to. Last 2, 3, 4, 5. From the figure above, what is the volume of concrete? Okay, so, tandaan niyo na we're talking about this. Ito, dimension. Ayan ang dimension. So, multiply mo. Incidentally, walang length perpendicular to the screen. Kaya, L is, whatever it is, multiply mo to get the volume. Same, normal weight. Because we're talking about concrete, know the normal weight of concrete. So, multiply this by the volume. So, the weight of concrete multiplied by the volume will give you the total weight of this. Yun lang. So, you have to know the Z because we are not given the distance perpendicular to the screen. Yan. So, last few, eyeball, this is schedule. C4, from the given schedule, what is the volume of concrete for footing C4? Ayan, volume of concrete. Ayan. Ayan naman ang dimension. Multiply mo na. So, pagka may column, may ano ka, table, kukunin mo na lang dyan, 2.2, ayan, 2.2, 2,000. Gawin mo ng meter, kaya divide mo ng 1,000. Ayan. Alright. Next, same. C10, what is the weight? But this time weight, but you're given the dimension. Kaya gawin mo, kunin mo yung volume, kinuha mo yung volume, and then, pagkatapos mo kuhanin ng volume, teka, what is the weight of rebar? Okay? So, kinuha mo muna yung volume. Ayun, separate mo, hanapin mo, you can count the number of bars along this direction. This is how to do it. 750 divide mo ng, kasi may spacing, di ba? Ito may spacing siya, oh. Ayan, center to center. Okay? Therefore, divide mo. Okay? So, therefore, pagkatapos mo divide, makuha mo yung number of bar. Ayan ang kanyang length. On the other side, yun din. 250 divide mo ng spacing, makuha mo yung bar. Ayan, next, ipasakasmay mo na. Tapos, yung total volume niya, i-multiply mo lang ng kanya. Kasi pag nakuha mo yung total volume, makuha mo na yung weight because you have naman this. Okay? So, it needs computation, but it is as easy as what you think. Because it's just simple arithmetic. It's just a matter of knowing the volume formula and then the weight of the concrete and steel. Oh, last few. How thick is the footing that supports column A? Saan ang column A? Ayan. Ayan, 475. Last, what kind of footing supports column B3 and 4? Where's that? B3 and 4. So, what is this kind of footing? Trapezoidal. Incidentally, wala sa choices. So, in-insert natin. How many top bars? Kasi wala tayong figure. Medyo, dito tayo magbabase. Nagkataon lang na. Is it 4? So, mayroon tayong 2. Mayroon tayong 2. May 2. So, alin ba talaga diyan mag-govern? I cannot choose 2 lang kasi we have to choose the maximum. Unless, pare-pareho lang sama sila. Kaya nga, may mga tanong na need to verify it with proctor kasi mahalaga na meron kang figure. Otherwise, if you base it on this, punta ka sa top bar. So, asan ang top bar mo? Ito yung top bar. So, may dalawa ka. May left, may middle. Yeah. So, definitely we'll take the formula. So, this is the last. These are braces used to provide resistance. It reduces reflection. It's a chevron bracing. Braces. Okay? So, it provides additional stability. Pero, paano mo nalaman ang chevron niya? Reduces reflection, transfer load. It helps greatly reduce size, structure. Sana lang meron siya dito kasi lahat naman ito, oo nga, chevron lang talaga. Chevron lang talaga ako pwede. So, given 300 by 300 column, okay, ano daw ang length ng tie, non-pre-stress, but this is 10, okay. So, ang answer is 1,000, nakasagot na natin ito kanina, sorry. 300 by 350, the same procedure. Okay, the same procedure. What is the length of that stirrup? That 816, at saka rectangular siya. 820, paano nangyari? Okay, so ito yun, assuming ito yun. The total length is perimeter plus 6 times 2 times ito, meron ng times 2. Okay, 820. So, perimeter plus itong nakausli na yan, yun lang. Bakit 75 ang cover? Dahil ito ay grade beam, nakadikit sa lupa. Given the figure above, what is the length of the stirrup? Okay, so, again, 900, paano nangyari? Pwede, kunin mo uli ito, may 40 ka, di ba? Okay, ito yun. So, minimum cover 75. Bakit 75? Ito ay, wala naman nakalagay. Naka-indicate. Minimum cover, bakit ano? I think, 40 lang. Okay, bago to minimum cover, tie beam kasi, I'm sorry. Bakit ganun? Saan ba nanggaling yung tie beam? Anyway, for this, type mo TV. Ala. Okay ha? Correction dito sa binigay sa ating figure. This is tie beam. Ang tie beam nasa lupa. Therefore, you have to change this to 75. Reason why I use 75, sorry. But given 40, pwede gamitin 40, binigay 40. Pero dapat 75. Ha? So, the same procedure. Discuss different types of settings anyway. Ang setting natin is in 30 minutes, dapat nag-set na siya. Wala ka nang dapat galawin. At nag-harden siya after. Nag-harden na siya in 10 hours. Complete tayo. So, never mind this. Just additional info. To avoid honeycomb and voids, to avoid honeycombs, you have to use this. All the above. Ito yung mga specs ng ating aggregates. 373. All things being equal, larger aggregates will produce stronger. That's true. The maximum clear spacing between spirals, 75, minimum 25. The minimum clear spacing between spiral, 25. Discuss spacing, well, direct from the plan because we cannot compute. For now, I'm just showing you this because I want you to know how complicated that is. It is not easy to discuss now. It needs design. Just to give you idea how you will get it. And I'm sure this is the last. The figure shown above utilizes framework of diagonal intersecting materials which eliminates the use of vertical pull loops. This revolutionary system carries post-gravity lateral loads. It is very efficient and creates stiffness that is complemented by axial action of the diagonal members. Invented by Russian genius Vladimir Shukov in late 1800s, the system only began in contemporary sail design in 2000 with the London GLI Swiss blah, blah, blah. All projects of blah, blah, blah. It is said that this system is 21% less steel than standard. Ano ito? Diagonalized grid structure. It looks like a diamond. In one glance, baka ma-answer mo A, but it is a D. So, sorry my dear, it was not intended to delay, but it was intended to discuss. Hindi pa nga ako masaya. Gusto ko pa mag-discuss, but the time allotted for me is not enough. So, sorry for that. Kaya, I wish you good luck. And of course, God bless you. And tama-tama na delay konti ang ating board exam. You have more time to prepare. So, yun. Thank you. Shout out sa lahat ng mga masisipag. Thank you so much mga mga beautiful ladies and gentlemen ha. Okay, we can eat na. Bye. Naku, hindi ko nabasa yung mga tanong nyo. Sorry ha, kung mayroon man, through GPT na lang. I am willing to answer naman kung meron. Okay?